sectors, because this workshop will provide support for professional development both for science teacher educators and also for school science teachers in Indonesia to learn about action research. This workshop is a workshop series which will be continued in July and December this year as a part of Linking Science Education Program project and funded by the National Association for Research in Science Teaching. Ladies and gentlemen, behind the implementation of this workshop, there's work hard and committee and commitment organizing committee. Thus, I would like to deliver my sincere appreciation to all the organizing committee and also all organizations who provide valuable support for this event. And finally, as the Dean of the Faculty of Mathematics and Natural Science, the State University of Makassar, I would like to congratulate all of you for participating in this international workshop. We hope that this workshop will also be a starting point for future collaboration among participants join this workshop. Most importantly, we hope that this workshop can bring benefit for all of us, particularly for this improvement of the quality of science education in Indonesia. And in the end of our speech today, let's open this international workshop by saying Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for the Dean of the Faculty of Mathematics and Natural Sciences, Universitas Negeri Makassar, for today. All right, ladies and gentlemen, our workshop today will focus on the role of action research in science education. And let me introduce our keynote speaker today, Professor David F. Triguest. And also for greeting from the team project, let me introduce the team project from LSEP. The first is Dr. Heian Chu from Macquarie University, Australia. And the second is Dr. Faisal from Biology Department, Universitas Negeri Makassar, Indonesia. And also the third is Dr. Rachel Ruggiero from Washington University in St. Louis, United States. All right, ladies and gentlemen, our keynote speaker today is Professor David F. Triguest. He is a John Cartin Distinguished Professor from the School of Education, Cartin University. And as invited speaker, we will have Dr. Heian Chu. She is a lecturer at Macquarie University's Department of Educational Study. And also we will have Dr. S. Ravindran. He is a master teacher at the Academy of Singapore, Teacher Singapore. Ladies and gentlemen, as the workshop presider today, we will have Dr. Nurwati Jam'an. She is a lecturer from Mathematics Department, Universitas Negeri Makassar, Indonesia. And also, we will have Dr. Rachel Ruggiero from Washington University in St. Louis, United States, also as workshop presider in today's event. All right, ladies and gentlemen, without further ado, let me hand over the session to the workshop presider.
Alright, thank you Mrs. Citra. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning everyone. My name is Nurwati from Mathematics Department. I'm going to be the moderator for the keynote speaker session. The Honorable the Dean of Faculty of Mathematics and Natural Sciences, the Honorable all the Vice Dean of Faculty of Mathematics and Natural Sciences, the Honorable all our distinguished speakers, the Honorable Head of Department, lecturers of faculty members, and all the participants. Ladies and gentlemen, I'd like to welcome you all to the International Workshop of Asian Research in Science Education. I'll do some introduction, but before that, just quickly going over to our agenda. Now until 9:45, we have keynote speaker Professor David Treges. After the tea break, we also have another two empathic speaker, Dr. Hyun Chu and Dr. S. Rabindranath, who will further explore them. Allow me also to remind our some house rules for the participants. Please mute your microphone unless you are speaking. Feel free to type in your questions and comments in the chat room. Alternatively, you can use the raise hand button to ask a question, especially in the Q&A section. And this international workshop is recording. All right. Before the presentation from our keynote speaker, let me introduce our keynote speaker by reading his short biography. David Treges is a John Curtin Distinguished Professor at Curtin University in Perth, Western Australia. John Curtin Distinguished Professor is the highest honor Curtin University awards its academic staff. He is an eminent researcher in science education. Professor David Treges from Curtin School of Education is regarded as one of the most prolific and significant Australian researchers in science education. He has been recognized internationally through his association with the National Association for Research in Science Teaching in the United States, the Christian Albert University of Kiel in Germany, and the many international students whose research he has supervised. For example, he supervised research students on topic identification, design, and implementation of intervention strategies to challenge students' conception, design of diagnosis tests, student use of analogies, and also multiple representation. He is the author of more than 350 publications in major journals and books on science education research and chemical education research. His work is well cited, with the Google Scholar H-index around 94, representing more than 35,000 citations. Wonderful, sir. Well, good morning, Professor David Treges. Nice to see you again. I'm Nurwati.
Nice to see you.
Nice to see you, Nurwati.
Yes.
So Sabri there. Wonderful.
Yes, sir. Yes, sir. I owe an immense debt of gratitude to you, sir. Well, to save our time, I'm very glad to welcome Professor David Treges, who will present Understanding Multiple Representation, an important key to learning science. The screen is yours, sir.
Thank you. I just got
Thank you. I just got to get myself set up, right?
Make sure I'm doing this.
Make sure I'm doing this.
Oh dear.
Oh dear. Right.
Right. Oh dear.
Right. Oh dear.
I have a new laptop.
I have a new laptop,
This might
and
be a problem.
this might be a problem. Let me have a look again. iPhone.
It's a share screen.
It's a share screen, and then it doesn't seem to work.
Share.
Share. So say share. Oh my God.
Nurwati, I
have to get a technical person to see if they can help me.
In the meantime,
In the meantime, let me send my slides to Faisal.
Is that okay?
Is that okay?
Okay, yes, sir.
You can hear me?
Yes, yes, we can
Yeah, right,
share
okay.
your screen from here, sir.
Right,
Right,
find Faisal.
let me find Faisal.
Right, oh dear.
Right, oh dear. There.
Okay, I've sent that to.
Okay, I've sent that to Faisal.
And in the meantime, I'll just see a computer technician here.
All right, sir.
What's happened to this?
What's happened to the program?
What's happened to the program? Ah.
You cannot see that, right?
You cannot see that, right?
No.
No.
Oh boy, excuse me.
Oh boy, excuse me.
Can share it, it will be good.
Actually, we already got your slides, sir.
Yeah, okay, good.
Yeah, okay, good.
So you did get them?
So you did get them?
Yeah, still trying to show in the screen, sir.
Okay.
Okay.
Yeah, sorry about this. I
Yeah, sorry about this. Well, I should have checked with Faisal the other day.
About that.
Didn't think about that.
Dr. Sabri is here as well.
Have you done it?
Have you done it?
Actually, Mr. Sabri is here as well, sir. Your
Yes, I
students.
know.
Are you able to open?
Are you
the slides
able to
for
open
me?
the slides? for me?
Yes, we're still trying, sir.
All right, okay.
All right, okay.
Yes, just a second.
I'm not sure what's...
All right.
Okay,
The
wonderful.
screen is yours,
Okay,
sir.
wonderful.
So you will
So
move the slide
you
along,
will move the slide along, right?
or can I? I think,
We will do it for you,
I
sir.
think you,
yeah, okay, good.
yeah, okay, good.
Okay, I'd like to.
Okay, I'd like to
apologize
apologize for the delay here. I've got a new computer and
things don't work.
things
like
don't
they did
work
before.
like they did
That's all I
before.
can tell you.
That's all I can tell you.
That's fine, sir.
Thank you very much for the
Well, thank you very-
information and also your very kind introduction. And I'm very delighted to be able to talk to you at Makassar. Of course, I know of the university, partly because of Sabri and Nuwati. So if you go to the next slide. Right, next slide. Okay, so what I'm going to do, I'm going to talk about multiple representations in terms of their contributing to enhance student learning. I'm going to talk about learning science with different modes and different representations. I'm going to give you examples so you know what I'm talking about and you will recognize many of these yourselves. I'm choosing examples in chemistry, biology, and physics. I'm going to talk a little bit about theoretical frameworks and then some examples from books. But I'm trying to make this as practical as possible. So next slide, please. So the rationale is that learning science with different modes and different representations can do many things. Can improve understanding of scientific conceptual knowledge. It can enhance problem-solving skills using different modes. And I'll explain what modes are in a minute. It can reduce difficulties in understanding the links between different representations. And most of all, it can lead to less fragmented knowledge and more coherent understanding. And in the situation in Australia, I don't think it's the case in Indonesia, we have a problem of falling enrollments in science. So it's hoped that this will increase enrollments in science in Australia. Next slide, please. So what do we mean by different modes and different representations? So different modes mean how things are being organized so you can learn. So it can be visual, it can be in writing, it can be verbal, and that means listening. You can be doing experiments like laboratory work. You can read quietly and absorb things. You can be discussing in groups. You can be doing mathematical problems. You can look at animations. And of course, the more technology we have, we've got virtual reality as well as things like animations. So each mode has got strengths and weaknesses that can help most students and people communicate their scientific ideas. So that's one aspect, modes. Now we can also organize and learn our scientific knowledge through analogies, metaphors, and models. And often these are presented as additions, but they should be integral part of learning. I was reading something the other day about models and students not having a model in their mind about light. So science concepts can also be represented at different levels of organization or perceptions. That is, the human eye, you can see things, or you need an instrument of some sort to see it, or it may be that you can't see it with an instrument at all. And one of the issues in learning in anything really, but science and mathematics, is the need to differentiate between what is real and what is a representation. And then we've got the notion of internal representations, which are mental models. Next, thank you. For me, this is one of the most wonderful paintings I ever saw, and it fits exactly with what we are doing. The translation is that this is not a pipe. So René Magritte is a Belgian surrealist artist. And I'm suggesting every science course should begin with this painting. Now, why do I say that? Because as soon as you see that painting, the obvious thing is you say, oh, that's a pipe. But he's written there, this is not a pipe. So it's a beginning of conversation that you can have about, is it a pipe or isn't it a pipe? And the notion is it's a representation of a pipe. It's a painting of a pipe. So maybe you begin your science classes with this particular painting. Right, thank you. Next slide. So I mentioned different modes, and I've got them here in terms of increasing abstraction. There are ways to externally represent scientific ideas, concepts, or phenomena. So we've got real objects. So if someone's bringing into a class some animals, for example, to a biology class, or chemicals in a chemistry class, or some toy cars into a physics class, those are real objects. And then we got actions. What people are doing with those materials. They might be making suggestions and saying, move things this way. So these are gestures. We've also got photographs of what is taking place. Often a lesson, you cannot go to the beach if you're not close to the beach. So you show a photograph of the beach, and that's sort of enough in a sense. You've got animations. You can write about what is seen. So this is now becoming more and more abstract. You can make drawings and diagrams and graphs. You can chart the data in tables. And then we're getting more abstract by having equations. We can write equations about, for example, movement of a body, like a little car on a bench. So we have an equation like force equals mass times ma. So F equals ma, and then we have more complex equations. And then you've got reading and reading from a screen, and then oral presentations like now. So you see the rate that you see how far down in terms of abstraction are paper-based text and oral presentations. So the argument of this multiple representations is you need to include other representations that are more observable and less abstract. Okay, next, please. So we also got this notion of levels of representation. I told you about things you can see or things that you cannot see. So in chemistry, we've got macroscopic representation, which is bulk properties of matter, things that we can see in the naked eye. So you have a rock, which has got something in it. It glistens, that might be gold, for example, or you have salt, sodium chloride that you buy in the supermarket. So this is what things look like. But of course, we know from our science that these things that we can see are made up of molecules that we cannot see. We can only see molecules with electron microscope. We can't see molecules with a microscope. So it's not observable to the human eye or even a microscope. And then if we want to communicate this information, we need to do it in terms of symbols. So we got the symbolic representation, which provides explanatory mechanisms of phenomenon. And you're familiar with this: chemical symbols, chemical formula, chemical equations, and of course, you've got numerical analysis that needs to be brought into here as well. Next, thanks. So here's an example from Peter Mahaffey. He's a chemistry academic in Canada. So he's got a nice organization here that actually gives you a very nice way of seeing this, not just reading about it. So you got water. This is a colorless liquid in a glass. Symbol is H2O. And then you've got a representation in terms of these molecular models. And then if you look at it in a different way, you've got the submicroscopic, which is a molecular model, and then the symbolic is H2O. The macroscopic, of course, is the water. Right, thank you. Next. So, often we talk about, in chemistry, something like this: combustion of methane. Now, this is not actually combustion of methane. This is a representation at a symbolic level of methane. So for combustion of methane, we need to see methane burning. And I do have a video clip, but I think it doesn't work right now. So what is methane? Methane is CH4. It burns. That means it burns in oxygen and produces carbon dioxide and water vapor. And so that's represented in a line there with the chemical symbols, and then it's represented in a different way with these molecular models. And the molecular models give the perfect understanding that for this reaction to take place, you need to rearrange the molecules, and you can see how that takes place. But I point out, this is not the combustion of methane. This is a bit like the issue of this is not a pipe. This is a representation of the combustion of methane. Okay, next, thanks. So what about physics? So representation in physics, we got macroscopic, which is referring to movement of bodies or observable light reflecting from a mirror. So that we can see. And then we got things at a molecular level or submicroscopic level. For example, understanding gas laws. We know that things are happening in physics when we're dealing with gases, and we have to represent it at a molecular level. And then again, we got the symbolic level. And the symbolic level provides explanatory mechanism for phenomena that have happened, like in this movement of a car or in the gas, that's represented by symbols, formulas, equations, and graphing relationships. And often, when we're learning in secondary school, it's often at an idealized phenomena. So for example, we deal with bodies moving across the surface without any friction. As soon as you bring in friction, you got a complication that probably cannot be taught other than in the last years of high school. Okay, next we come to biology. Oh, no, sorry. No, go back, please. So there's an example of representation that we've all learned at some stage in high school or college or university. A man pulls his child in a sled at a constant velocity. So there's a weight of the child and the sled. The force applied the handle is at an angle of 15 degrees. Draw a free body diagram, and then what's the normal force? So you have to do all this, and you can see for someone who doesn't know what's going on, this is kind of nonsense. But these arrows and the letters are actually telling us something. So that is the representation of that figure. Okay, thanks. So for biology, as those of you who are biologists will know, you have an additional level of representation compared to physics and chemistry. So you have the microscopic, which are biological structures which are visible to the naked eye. You've also got molecular, submicroscopic, which involve chemicals we can't see, like DNA, proteins. But between that, we've got something we can see under a microscope, which is cellular or subcellular aspects of say a plant. If you take a leaf and you look at it under a microscope, you can see all kinds of shapes, and these shapes are the cells of the plant. Back to the molecular, we need to know about that because we deal with activities like electrophoresis, chromatography, and centrifuge. So we know that things are happening. We can see it physically, but what's happening is at a molecular level. And then as before, we got the symbolic that provides explanatory mechanisms of phenomena represented by symbols, formula, chemical equations, metabolic pathways, and then we got numerical calculations. And you know from your biology, you're dealing with genotypes, inheritance patterns, phylogenetic trees in evolution, etc. So with chemistry and physics and biology, the argument is that a student needs to be able to integrate these different levels to have a good understanding of what's going on. If the student is only learning at the symbolic level, they might pass an exam about the questions dealing with the symbolic level, but what do they really understand about what's going on at a molecular or at a macroscopic level? Thank you. Next. So here are some examples. You've seen them before. A structure of DNA. And then you got the diagrammatic representation showing the different aspects of the DNA structure. And next. Here's another way of representing things in biology. By the way, you could represent things like this in physics and chemistry also. This is the kind of representation that one sees in magazines or even in the newspaper. So people get very used to reading these kind of diagrams. And this is a diagram looking at environmental influences in genetic disease. And so you have examples without environmental factor and examples with environmental factors. And of course, there's a lot of information behind that. I think from this little graph, the thing that's most important is diabetes, which has got a greater influence from environmental factors than genetic factors. And according to that, the same with cancers. Okay, next slide. Here's another way of looking at representations. I think what we are all used to in normal science classes are the diagram on the left. So the diagram on the left shows the lungs in a schematic way, and then we've got all these labeling showing what parts of the lung exists. In the middle, we have some kind of micrograph, which is looking at the lung in reality. And then on the right-hand side, we have some representation of what's going on in the lungs when we're breathing. So you can see there, they are increasing from left to right, going more and more abstract. Okay, next, please. This is another abstract representation with a program dealing with genetics. And it's very interesting. This program deals with like baby dragons. And so the way you deal with it, you've got the animal, which is the one in the middle, a blue animal. So that's what it physically looks like. And then you've got its representation in terms of chromosomes on the right-hand side, and representation in a slightly different way in terms of cells below. And then you got that phenotype with the symbols. And then below this sequence, the DNA sequence. I have to tell you, we've done some work with lots of classes with this particular program, and the boys love it and the girls are not so interested. The girls say, well, if we're going to deal with biology, why don't we deal with human biology? This is like boring. So very much a gender effect here with this kind of particular work looking at dragons. Okay, next, please. So this is trying to put everything together, and it just gives you a sense about those of us who are in this workshop have come to understand all these different aspects. That is, the different modes, the different levels of representation, and the different domains. But when you look at it like this, you realize how complicated this is for a learner, a young student. And so we have to be very overt about what we're doing. And I'll talk a little bit more about that in a minute. But just before we leave this, again, you can see, you got, just like I showed you before on this horizontal translation, you've got things that you can like touch, see. You've got photos of what you can see, you've got drawings of what you can see, you've got maps, diagrams, equations. So it's going to increasing abstraction. And you notice the linguistic is the most abstract. So if all you're doing is talking, that's only one way for a student to learn. And it's a more complex abstraction than it is learning from graphs or maps or photos or the laboratory work. Okay, next, please. I mentioned that it's always a good idea to have a theoretical framework. And I won't go into any detail here, but just to point out that if you're looking at how these different representations help someone learn, of course, you can do it in a simple way. and I think that's effective. If I've got a class of students and I've got them doing an activity like an experiment, they're collecting data, they're drawing graphs, they're writing about they're explaining the graph. These are all different representations, which is great. If I want to try and analyze it in some sort of detail, this function representation by Sharon Ainsworth, I think, is very good. So you're looking if the functions, are they complementary, or does one constrain the other? Do they construct a deeper understanding? And so if you're doing research on multiple representations, this is one theoretical framework that you can work on. Right, next. Okay, so I'm now going to summarize a few things, and then I will raise some other issues. So understanding multiple representation is an important key to learning science. Why? Different types of representation should be identified. So you actually be overt about what you are doing. The significance of the relationship between the representations should be emphasized. And as I pointed out at the beginning, if you do this, and if the students are able to do this, and this is students at any level, including you and me, it reduces fragmentation of knowledge, and it increases cohesion and understanding. And it helps students understand science, not just to memorize it. And I think this is very, very important. Okay, next, please. So what are the implications of learning with multiple representations? A combination of different representations enables learners to attend to the subject from different perspectives. So this is a really good thing to do, but it's not easy. So there might be some frustration in the teaching, but believe me, it's worth it. Learning with different representations provides new insights and construction of new knowledge, and it enables deeper understanding and coherent knowledge. However, the notions of representational competence vary across context, and they can be content specific. So you might have a class in chemistry, and the students seem to understand the representations very easily, I guess because they're used to drawing writing symbols and writing chemical equations. You bring that into physics or into biology, and it's not quite so simple. Next, please. So when students do not master the ideas of the different representation types, what can happen is they misunderstand the meaning of models and their use. So, for example, Okay, so I'm going to just introduce you without any details to 3 books which have been written, well, edited by me, and of course the people who provide chapters were invited authors, typically from all over the world. So this was the first book with John Gilbert, who sadly passed away last year. It's multiple representations in chemical education, and there's a lot of nice chapters in there. We had a foreword by Alex Johnson. Alex Johnson also passed away. He was, I think, the initiator of the idea of needing to consider this multiple representations when learning chemistry. The book was divided into 3 sections. We looked at challenges and improving pedagogy and what to do in the classroom. Okay, next. So the next book was Multiple Representations in Biological Education with Cheyenne Hsu. Cheyenne Hsu was a doctoral student of mine. He originally is from Hong Kong and migrated to New Zealand, and then he came to Curtin to do his PhD. So we did this together, and then more recently, next slide, please. Okay, next slide. Is this book, Multiple Representation in Physics Education? This is like 2 or 3 years ago. And this is with my German colleagues, Reinders Duet and Hans Fischer. And many of you will know that I've done a lot of work with Reinders Duet, dealing with conceptual change. So the whole idea of this was to have 3 books which dealt with chemistry, biology, and physics education to show the various types of multiple representations that are being presented in different parts of the world. Okay, next, please. So what I've tried to do in this short talk, and I'm happy to answer questions, discuss why an understanding of multiple representations is an important key to learning science. If you're only learning one way, through reading or through listening, it's not going to be enough to have a good representation of science. It also gets around this notion of fragmented knowledge. And there's a debate about this. Learning, should learning be in a cohesive way or a fragmented way? And what I'm saying is that multiple representations will help you learn in a cohesive manner. I illustrated the importance of using multiple representations to learn science. I examined some examples in chemistry, biology, and physics with multiple representations. I introduced this theoretical framework by Sharon Ainsworth dealing with functions. And I didn't do that because I've run out of time. I was going to talk about a case study with physics, but we ran out of time to do that. Okay, next, please. Okay, so those are some of the references, and that's the end of my talk. And I thank you for arranging this so you can move the slides along. And I'm sorry about the mess up at the beginning. So I'm happy to take any questions.
Right, thank you very much, Professor David Treges, for the amazing presentation. We're still calling for the questions from the participants. Anyone here want to ask a questions, please? Siti Fitriani Saleh, please. Go ahead, Ibu Siti Fitriani Saleh.
Yeah. Can you move the screen?
Can you move the screen?
Close the screen, I think.
Close the screen, I think.
Okay?
Okay?
Yes, yes, sir. Siti Fitriani Saleh wanna ask something, sir. Please, Siti Fitriani Saleh.
Okay, thank you very much.
Okay, thank you very much, Dr. Nurwati. Thank you very much for the time. I'm Siti Fitriani Saleh from Universitas Muhammadiyah Makassar, Mathematics Department.
Thank you very much.
Thank you very much, Prof. This is a very inspirational presentation, I think. You've explained level representation for chemistry, physics, and biology.
But in math,
ideally in mathematics, we also use leveling, which is similar to what you described, macroscopic, microscopic, submicro, and symbol. But in practice, we have problems with the time to complete the subject matter, especially in Indonesia. Which encourage our teacher to directly show the equation or formula and how to use the equation. They don't start with the real thing and then the picture or diagram or etc. But directly to the equation.
What's your suggestion to overcome the problem of limited time in school and class in using multiple representation in learning? Maybe about the task, Prof, that you've not yet explained.
I thank you for the question. I think this is the most important issue for teachers. But what teachers need to be convinced about is that if they do find some time to use different representations, rather than jumping straight into writing equations, then they will find that the students have got a better understanding and do better on exams. And some years ago, we did some work with teachers here in West Australia who spend a lot of time at the beginning teaching students different representations, and the teachers became very frustrated by saying, "Oh, we're not covering the lessons." And myself and another teacher were working with these other teachers, and we said, "See what happens in week 3." Oh, they finished week 3 in 2 days because they understood what they were doing. So I think the teachers got to be convinced that in the first few days or weeks, they spend more time, but then the students speed up with their work. So you as a teacher educator have got to convince the teachers that this is worth doing. Very good question and a very important issue.
Thank you, Prof.
Yes.
Thank you very
Thank you,
much.
Prof. Thank you very much.
Okay, thank you, Bu Siti Fitriani Saleh. Next, from Herma, please ask your question, Bu Herma.
Apa bisa ditranslate?
You can say in Indonesia or in bahasa, Bu Herma.
Oke. Terima kasih atas kesempatannya. Yang ingin saya tanyakan adalah seperti yang kita ketahui setelah saya mengikuti tadi presentasinya, saya merasa penting sekali mempelajari kunci mempelajari seperti tadi ada yang dibilang simbolik, subsimbolik dan makroskopis dan mikroskopis. Nah, yang ingin saya tanyakan, apakah di tempat Bapak pelajaran kunci mempelajari sains ini, kunci dalam mempelajari sains ini diajarkan di sekolah dalam pelajaran khusus atau langsung di dalam konten pelajaran IPA. Misalnya kalau di biologi memang ada di dalam buku yang pertama sekali harusnya dipelajari itu adalah kunci dalam mempelajari ilmu sains, atau hanya diajarkan pada saat pengenalan lingkungan sekolah atau di waktu-waktu lain, atau memang harus ada di dalam buku biologi. Karena ini sangat penting sebelum kita mau belajar, harus memang kita pelajari kunci dalam mempelajari ilmu sains ini. Ya, itu yang ingin saya tanyakan.
Thank you, Bu Herma. Actually, Professor David, Miss Herma asked a question. He realized that the importance of multiple representation, especially in biology subject, she asked about what about the multiple representation? So we provide like certain or specific. So sorry for the. Actually, Miss Harma asked about so we make like a specific class for the multiple representation, or we can apply this multiple representation within our biology class.
Right.
Especially in Australia. What about in Australia? He asking about in Australia, sir.
I think teachers are becoming more and more sensitive to these issues. Yes. So we're working with some teachers right now where the students are doing activities, and we're asking them to represent what they think is happening at a molecular level. And so the students can't see anything, but they're trying to represent it, and in doing that, they're thinking about what is happening. For example, when we do a chemical experiment, which might be separating a mixture from a soluble and an insoluble chemical. So normally you just do the activity, but then we go one step further and say, well, what do you think's happening with this separation of the insoluble and the soluble chemicals? So this is not something that is imagined. A lot of the aspects that I showed you are taking place in classrooms everywhere, and I think also in Indonesia. Although it's a long time since I've been in Indonesian classrooms.
Thank you, Professor David. Next from Abdul Rahman, please.
Professor Dabot, hi. Professor Dabot, hi. I think it was, hi. So it's very insightful presentation about representation. So I want to follow up with Ibu. That's the first question, asking about. I mean, I try to put it in the context of Indonesia, where the teachers, when they teach science, when we compare with your continuum of representations, they will start with the very abstraction state, which is the explanation or textbook based. And I think that's one of the big issue that teachers they don't have the lack of competence of trying to represent the real happenings, things with naked eyes into the classrooms. First, because of, for example, the time constraint. The second one, because of the curriculum. Okay, and then the third one, maybe the infrastructures, because most of schools they don't have any kind of labs. So my question is, in this kind of context, how to balance? Okay, how to balance between what is in terms of the continuum of representation. So how to balance from moving upward from the most abstract one to the real one. Okay, and then the second one is also about you mentioned a couple times about fragmented knowledge. Okay, I think this is what happens. I think this is what happens within the education. Most students, when they couldn't connect it with what they know, what they learn from the class, with what's happening in their real life. I think that's my question. Thank you.
Yeah, you raise extremely important issues. As I said, I have been in Indonesian classrooms, and I realize that sometimes you don't have labs, and I know that in some classrooms you got many students. But I think even doing a demonstration and having students involved in the demonstration, so they actually get a physical event taking place in their classroom. And I mean, this can be done with chemicals from the kitchen, if you like, or bringing a plant or an animal into the classroom, or dealing with in physics, you could bring a bicycle into the classroom, for example. So what I'm trying to get at is you try and make things as real as they can be, rather than be abstract. So that's the first thing. The point that you raised about the time allocation. I think all teachers have got this problem, and my understanding is that the Indonesian curriculum is looking to become a bit looser. Am I correct about that? So there's less information to be presented in a longer period of time. Am I correct about that or not?
Used to be, actually, but we're moving forward to be more contextual in terms of what students understand in the classroom, and then they see what is it like in real life.
Yeah, good. Yeah, I know one of my ex-students who's a colleague at the University Negara Yogyakarta. He has been looking at learning with social science ideas, learning science with social science ideas, and it tends to work out very well. Students get into debates, they take on a role, and they learn about, for example, if it's dealing with environmental science, so you got a topic and it might be pollution. So people take on different roles and argue the points, and it works out very, very well. And he's not the teacher. He's been working with teachers, and the teachers seem to function well. We've written a few papers about that. So, and there's another one to come. Thank you very much.
Thank you. Thank you.
Session, we still have a panel discussion, so I'll take a question from the chat box from Miss Arifa Novia Arifin. She asked about how to deliver our material with the different academic of the students. how to deliver, how to best deliver our lesson for a different academic level of our students.
Okay, this is
a
very common
point, isn't it? That you
typically the lower grades, whether it be in primary school or lower grade in secondary school, you need more activities, because students, if you think about this notion of learning by doing, then you need more activities at the lower end of the education system. And then as you move up the years, then I think you still need some activity. You don't want to make it abstract, but you can lessen the amount of time that you're doing activity work. So teachers are typically a very good judge about what I teach in grade 5 and what I teach in grade 10. So it might be the same topic, respiration, for example, of plants, and the teachers know what to teach in grade 5 because it's in the curriculum and it's in their experience, and what they teach in grade 10. So again, the representations on that diagram of going from more concrete to more abstract, for many students, they need to have experiences at the more concrete level. Thank you.
All right. Thank you very much,
you.
sir. As I said before, we have a panel discussion, so sorry for the questioner that I can't present your questions right now. I'll take over to Dr. Rachel Requirela as a project team to accompany our panel discussion. Time is yours. All right. So okay. So this session is end. All right.
Yeah, thank you.
After the tea break, we have a session with with our invited speaker. So thank you very much, Mr. David. You are our inspiration for a dedicated staff and professor who has no limit to serve for others and very productive in academic. Thank you very much, Professor David Treges. Hopefully we'll see you again. Thank you. I'll turn it over to I'll turn it over to Ms. Chitra.
Thank you.
Thank you.
Thank you.
All right, thank you very much for our presider, Dr. Nurwati Jaman, and also thank you very much for our keynote speaker, Professor David F. Treges. That was a very insightful presentations regarding the multiple representations in learning science. All right, ladies and gentlemen, now we are having a tea break until 10 o'clock, and after that we will have invited speaker sessions, which will be delivered by Dr. Heian Chu with the topic of the arts integrated STEM approach in science classroom, and also Dr. S. Ravindran with the topic of action research insight from a school-based PD approach in enhancing PCK of secondary physics teachers in Singapore. All right, ladies and gentlemen, please have your time to take a break. Thank you very much.
Thank you.
Thank you.
Thank you very much.
Thank you very much.
Selamat datang di Universitas Negeri Makassar. Adalah salah satu perguruan tinggi negeri yang ada di Indonesia, terletak di Makassar, Sulawesi Selatan. Memiliki visi yang kuat untuk menjadi pusat pendidikan, pengkajian, pengembangan ilmu pengetahuan dan teknologi, dan seni yang berwawasan pendidikan dan kewirausahaan. Untuk mencapai visinya, Universitas Negeri Makassar menyelenggarakan kegiatan Tridharma untuk menghasilkan sumber daya manusia yang profesional dalam bidang kependidikan dan non-pendidikan. Memberikan layanan kepada masyarakat untuk peningkatan kualitas hidup masyarakat. Menciptakan iklim dan budaya akademik yang kondusif sesuai dengan prinsip tata kelola yang baik. Mengembangkan Universitas Negeri Makassar menjadi riset university yang dapat memenuhi kebutuhan pembangunan bangsa. Mengembangkan jejaring atau kerjasama antara pemerintah, swasta, ataupun instansi dan lembaga pada tingkat nasional dan internasional. Adapun tujuan dari Universitas Negeri Makassar adalah menghasilkan lulusan yang profesional yang dapat diterima sebagai warga masyarakat yang berbudi pekerti yang luhur, terwujudnya universitas mandiri yang bertata kelola yang baik sesuai dengan peraturan perundang-undangan, menghasilkan produk ilmu pengetahuan dan teknologi serta seni yang bernilai kewirausahaan, terwujudnya jaring atau kerjasama profesional dalam bidang pendidikan, penelitian, pengabdian kepada masyarakat dengan pemerintah pusat atau daerah, BUMN, swasta, institusi dan lembaga lain baik pada tingkat nasional atau internasional untuk kemaslahatan manusia. Meningkatkan kualitas penyelenggaraan pendidikan yang syarat dengan atmosfer akademik yang sehat sehingga tumbuh berkembang kemampuan intelektual dan sosial secara terpadu sesama sivitas akademik. Untuk mencapai visi, misi, dan tujuan itu disusun 7 program strategis yang sudah dicanangkan dalam program kerja 2016 sampai 2020. Pengembangan kapasitas dan manajemen organisasi atau lembaga, pengembangan inovasi pembelajaran yang berbasis teknologi informasi dan komunikasi, peningkatan mutu penelitian, pengabdian kepada masyarakat, demikian juga publikasi ilmiah, peningkatan sarana dan prasarana, serta penataan lingkungan menuju kampus yang modern, pengembangan karakter mahasiswa dan alumni, peningkatan tata kelola keuangan dan kesejahteraan dosen, perluasan tenaga kependidikan dan mahasiswa, jejaring kemitraan, dan publikasi antar lembaga. Dalam kurun waktu 2 tahun menjalankan ke-7 program yang strategis, Universitas Negeri Makassar sekarang sudah memiliki 9 fakultas dan 1 program pasca sarjana. Fakultasnya adalah Fakultas Matematika dan Ilmu Pengetahuan Alam, Fakultas Teknik, Fakultas Ilmu Keolahragaan, Fakultas Ilmu Pendidikan, Fakultas Bahasa dan Sastra, Fakultas Ilmu Sosial, Fakultas Psikologi, Fakultas Seni dan Desain, dan Fakultas Ekonomi. Universitas Negeri Makassar telah meraih Standar Nasional Indonesia SNI Award kategori Organisasi Perguruan Tinggi Seluruh Indonesia. Universitas Negeri Makassar menduduki peringkat ke-20 sebagai perguruan tinggi non-vokasi terbaik se-Indonesia. Terdapat 31 program studi yang sudah meraih akreditasi.
Alright, ladies and gentlemen, welcome back to the International Workshop Action Research in Science Education. Alright, ladies and gentlemen, now we are at the invited speaker session, which will be delivered by Dr. Hyeon Chu from School of Education, Macquarie University, Australia, and also Dr. S. Ravindran from the Academy of Singapore Teachers, Singapore. In this session, as our workshop presider, is Dr. Rachel Ruggiero from the Institute for School Partnership, Washington University in St. Louis, United States. All right, ladies and gentlemen, without further ado, let me hand over the session to the workshop presider.
Hello.
Hello.
And welcome.
And
Thank you so
welcome.
much.
Thank you so much.
I believe
Dr.
Chu is sharing
Dr. Chu is sharing her screen and getting prepared
for her talk. And just oops. Are you all set, Dr. Chu? Sorry, screen. So, Dr. Chu joined Macquarie University's Department of Educational Studies as a lecturer in January 2015. And before joining, she was assistant professor in natural sciences and science education academic group in the National Institute of Education in Singapore. And she has coordinated and taught undergraduate and graduate courses in physics, assessment and science education, carried out research on students' conceptual development and beliefs in science learning. And she is here today to share about arts integrated approach to STEM in science classrooms. And so I will turn it over to Dr. Chu.
Thank you, Dr. Rachel. I appreciate for this opportunity to share my research here with you. Today's my research is about arts integrated STEM in science classrooms. These presentations were prepared by these two projects. First project was about developing innovative teaching approach as a product of interaction between Australia and Korean science educators. Second project is to investigate the effects of the STEAM teaching approach on student conceptual understanding and perceptions of science learning. Here are our project team. I worked with Seoul National University, Sonia Martin, Dr. Jinung Song, Dr. Chang Jong, and from Macquarie University, I worked with Professor David Trust. Here are school teachers, and we have 4 school teachers in Korean schools, 3 school teachers in Australian schools, and 5 undergraduate students who already finished their study on this STEAM topic, and those 2 are still working on this STEAM topic. This is my outline, today's presentation. I will talk about the difference between STEM and STEAM, I think STEAM is now getting popular, so everyone knows the differences. But I will tell you what is our interest in STEAM. Then I will introduce the project program we call it as an intercultural STEAM program. Then I will introduce you our research focus. There are several different research focus, but I will introduce only 2 today. Even though STEAM has strengths, there are concerns and challenges in schools and among teachers. So I will talk about concerns and challenges as much as I can. I will address the challenges. Okay. Before I start this presentation, I went to the Google Scholar and searched. My keywords was STEAM in science teaching in Indonesia. I found that there are about 9,000 publications in Indonesia since 2018. Korea, there are 14,000 because they started STEAM since 2012, and it's part of their national curriculum. There is a special issue. This is Eurasian Journal of Mathematics, Science and Technology Education, the journal. You can find many Korean papers about STEAM education. We also have Asia Pacific Science Education. This journal, it's open access. So if you click this one, you can download almost all STEAM papers. So we prepared the STEAM education in the science in the Asia Pacific region. There are lots of papers about STEAM. From this journal, even though it was published 2021, the papers downloaded more than 6,000 times. It means that many science educators are really interested in about the STEAM. However, STEAM is not one concept. Each research groups and each country defines STEAM differently. So here, traditionally, the difference between STEM and STEAM, like traditionally STEM learning involves a multidisciplinary approach in which each components are learned separately. In the other hand, STEAM education attempts to provide students a more holistic learning experience by integrating math, engineering, and humanities with science and technology. These are the common differences and people normally talk about. However, our research team think arts integrated STEAM is arts integrated approach to learning science. Those STEM contents we considered as a starting point. It means that we are applying STEAM, integrating arts around the STEM to teach science. So here, our STEAM is to guide student inquiry, dialogue, and critical creative thinking. And the STEAM student will become better at problem solving, and the student can make a connection between their science learning and the world around them. This is what our research team mean about STEAM. And we think that by encouraging students to engage in STEM through alternative pathways, such as arts, creative art, literature, history, music, as well as like cultural events, social cultural practices. I think it helps students to remove some limitations of learning science, so we can provide more opportunity for students to learn science. So we consider STEAM as equity of providing STEM learning opportunities to all students. Now I will introduce our STEAM program. Since 2016, we have developed 7 modules. Module 1 is about light and seasonal change, wetland constellation. All the modules, we selected the key science concepts and tried to integrate art components. Those kind of artistic components were integrated. Student has to represent understanding of light by designing and sharing their own artwork, reflecting individuals' culture. So we introduced the science topic, but integrating with the arts along the lessons. There is a seasonal change. We especially emphasize the geographic differences. So Korean student met Australian student. They asked about whether their culture, their school life there, then they ended up about explaining why we have different seasons. This one especially, we focused on developing student conceptual understanding of the seasonal change using model-based learning activities. Recently, we are integrating social scientific issues into STEAM. So now we start to call our STEAM program as SSI-based STEAM program. So module 5 is about forest around our schools, and module 6 will be about climate change, and module 7, we selected the physics concepts, but it's about designing zero energy house. So students have to consider socio-cultural practices in Australia and in Korea, and they design house or schools for each other. So Korean students design house or schools for Australian school, and vice versa for Australian students. Because this module is targeting creative thinking skill, we want students to use more creative thinking skills. So we had these 7 modules, especially the first 4 modules we developed based on these 3 main goals. We want to promote intercultural communication and science learning. It means that we actually make a student to meet each other through online, Zoom or Skype. It was very difficult in 2016, but now it's really common. And right now we only did this research between Australia and Korea, but in future, if it's possible, we can engage different groups of partners, for example, Australia and Indonesia. We employ engaging pedagogies, for example, the 5-way inquiry cycle lesson design were used to all 7 modules. And inquiry teaching design, the model construction, model-based pedagogy were used for seasonal change. Scientific creativity were used for zero energy house module. And most of the modules employed multiple modes of representing knowledge. speaking, writing, drawing, designing. So we want students to use different modes to present their understanding. We also wanted to integrate technology because communication have to be happen between two countries. We used many technology tools for communication purpose. For example, voice thread, Zoom, website like Google Site, Padlet. We also use technology for the activities. Floor plan, design tool, house design tool, augmented reality for students to think about abiotic and biotic components. All those modules were designed based on those framework. We want the student to work together because knowledge is co-constructed by learners. So in that way, students can work and construct their knowledge socially and culturally, and they may hold multiple perspectives about the same issue. We pay attention to the affective domains of learning. We believe that personal beliefs and values will play an important role in learning science. Lesson requires, based on those framework, group discussion and sharing their ideas. Student has to be actively engaged their dialogue, and they have to share multiple perspectives. Here are like examples, classroom demo by demonstration by teachers, then follow-up classroom discussion, small group experiments and activities, and using prepared worksheet, they did individual investigations. Most of the modules adopted guided inquiry rather than open inquiry for our programs. And the communication was emphasized for each module. As I mentioned, the whole class discussion, small group interaction, and also keeping their summary on the Padlet or Google Documents. They also made their video diaries to share it with the peers in small groups. Also, they shared this kind of video diaries with the Korean students. And Korean students shared their video diaries with the Australian students. All these activities helped students to develop their concept and actively engage in science lessons to promote their positive perceptions about learning science. These were our research focus. So we focused on student concept understanding around the STEM contents. We also did some teacher interview, teachers' appreciation or beliefs of the need for integrated curriculum approach like STEAM. And we wanted to see how the designed program can be implemented in the science classrooms. So researchers developed the program, but when we work with the teachers, we ask the teachers to modify the program with the good reasons. So that way teachers can include their own observation, their own views in science classrooms. They could make those research turn into their action research. And also we want to observe how STEAM can improve student active engagement in science and increase student positive perceptions towards science learning. We had a questionnaire, but The questionnaire did not give us good response, but interview gave us really strong response. Student engagement were observed through video recording. This one was interview and questioning. The other one, we want to see how STEAM can expand students' awareness of similarities and differences with students in other countries and culture in general and in relation to STEAM application specifically. Those differences, similarities, provide them critical thinking and creative thinking skill opportunities, developing skill opportunities. Lastly, this one we planned it, but we are still working on. We want how STEAM can improve achievement and engagement of students who are traditionally marginalized in school science and mathematics. I mean, the above research focus, we have lots of data, but this one we are still working on. So as example of student response related to our research focus, student conceptual understanding about STEAM content, here is our case one. As we explained above, we adopted model-based teaching approach, especially we used the explanatory model. So students have to provide their initial model, so individual initial model. Then after doing some hands-on activity designed by teacher, they have to produce their middle model. This middle model, they produce in a group, then do hands-on activity again, then they produce the final target model. It's all explanatory models. So you see here the process of joint evaluation and modification of student models lead to growth of understanding of science concepts. But in between, teachers were able to monitor their alternative conceptions, their correct conceptions, and they decide which hands-on activity they should include in the science, in the lessons. So again, here teacher is the main person who decide which activity they want to provide to the students. So from the case one, we found out that their initial model is before learn about the topic. This is, I think, I took from primary school classroom, primary year 5. So their responses is not at all scientific, but after they have some group discussion, they had some hands-on activity and group discussion, you can see that their responses is more improving towards science explanation. But still there are gaps. They could not connect the tilted axis and the seasonal change. After they have a teacher showed some video clip and some hands-on demonstration, then they arrived at this final model. When we read through this final model, now they use the lots of scientific terms like revolving, tilted axis. They even use what's happening in Korea, what's happening in Australia, why we have different seasons. So before they arrive at this final explanatory model, we had 2 to 3 times Australia-Korea student interaction plan for 10 to 15 minutes. So they talked about different seasons. They also shared why they think we have different seasons. All those processes really helped them to arrive this final model. And everyone was so excited, not only for students who like science. And here, second case is from the light module. We especially focused on inquiry-based teaching and learning process. From the beginning, teacher showed some kind of media facade, like Light Festival in Australia, media facade at the palace, in traditional palace in Korea. Then they had the Korea-Australia student interaction. After that, students begin with asking questions. These asking questions triggered by an experience in their social cultural life after teacher presentation and after their meeting with other country students. I will show you later what kind of questions students asked at the secondary school science classrooms. Then students attempt to generate an explanation about their question. They selected one question in each group, then try to explain it. Again, after that, teacher prepared some hands-on activity based on their explanation. So students are now engaged in hands-on and all those information and communication technology, medicated teaching learning activities designed by teacher. After they have this one, they start to explain, answer to some worksheet and explain their understanding about given phenomena. I will show it to you later. This is student-generated questions. I selected two. I have more in my book chapter, so you can read it later. I will give you the references at the back. So after student watched Gyeongbok Palace media facade and Sydney Opera House, this media facade during Vivid Festival, the Vivid Festival finished, I think, last week, a few weeks ago. I'm not sure it's still on or finished. And then meeting with the Korean, Australian students, and they talked about cultural things related to these patterns, color. They asked so many things each other. Then these are questions they produced, nice questions. What is the connection between the brightness of light and the type and the nature of the material used to construct the building at Sydney Opera House or South Korea's Gyeongbok Palace? So from this question, they were able to explore reflection of light depending on smoothness, reflectiveness, and color. They also were able to see something about optical illusion. And the other question was, why do we have light festivals only at night? And then from this question, this group were explored the human eyes perceptions of a light source. So all those inquiry questions were generated by students, and then these questions helped directed the teacher's planning of investigative activities that guided the student to construct the science concepts. So as a researcher, we had a little bit of a prediction. We designed a few activities, but there were more ideas came in from teacher's side. This is the phenomena they have to explain. So after they learned a few science concepts from these questions, now they have to apply it to the new situation. So they made this quasi hologram using PowerPoint slide. And this one is like on the floor, this is mobile phone, and see the pyramid shape like film, and then the image is floating in the air, and they have to explain why it's like this, what is it. So they have to apply the reflection, optical illusion, all those things here. So student 1 says that the light from the table reflects the image onto or into pyramid. So it looks like a hologram. Nice answer, but there are better explanations like this. The light on the iPad reflecting on the pyramid into person's eyes, which is clear, and in the person's mind, it seems like it's the image is floating in the mid-air. So the student tried to explain how we see things. And they were again engaged when they create this image, because they have to use their own identity. So this student lived in Korea, America, and now she's living in Australia. So that's why she made this pattern. So when they explain about their artwork, they have to explain what this pattern means and what is the science concept applied, how we can enjoy this artwork using science concepts. So this is my last research question for this presentation. Student active engagement and positive perceptions of science learning. Student active engagement were only able to observe during their activities, during their discussions. And also from interview, they all mentioned that how it was exciting and how they really enjoyed the learning science this time. So here, student L mentioned that this is coming from case 2, the light. They say, I actually never thought that this stuff, for example, light festival, holograms, have anything to do with the science concepts I learned at school. It's impressive that how science can be used for art. This was great student response. And this one also coming from the light module. They say, my science classes were very complicated, but this is STEAM program. So they think the previous traditional way is complicated. The STEAM program exciting, and then the student realize how light works. So all those points we intentionally designed for students to use these arts and use social cultural practices when they learn science. It worked very well. Learning science means for them reproducing the correct knowledge, but it's very difficult traditionally. But when they try to apply the knowledge based on their understanding, their words, into artwork, actually it intrinsically interesting and engaging for them. So summary here, we found out that integrating arts into science make a student really think science is really connected to their everyday life, artwork, everything. And also here, art-related event or social cultural issues in a community conversation could be the key components for students' active engagement and changing their perceptions of learning science. However, even though there are lots of good things, there are concerns and challenges. For example, the difficulties of STEAM teachers, science teachers, face in integrating arts-related content with the teaching science. Also, all different components of subjects. Teacher has difficulties of understanding the learning outcomes from the subjects and teaching approach, teaching strategies, that was the main problems. And STEAM integration is really based on inquiry and also encouraging creative thinking to solve problems. However, the exam system at school is different. So there was some conflict between inquiry approach and school exam system. So these were concerns and challenge. We tried to address that, like reorganizing curriculum. It's very common in Korea. And also in Australia, when I apply STEAM at schools, teachers reorganized their subject curriculum. Science, art, math, sometimes math, art, science, it was flexible. And we really think we need a professional development program for teachers to understand how to integrate arts into STEM topics. So right now, this is our current study. We are trying to make a short program for teachers to use the systems thinking to integrate arts component into science program design. So this is what we want to do. We want teachers to improve their mindset, like they really want to do this STEAM because of you. And content is content knowledge, science, and some understanding about art and the structure and behavior. This is our current studies. So in 2016, we had this STEAM symposium in Australia. This year, 2022, October, we couldn't decide the date, but we will have a STEAM symposium here again. All the plans workshop will be posted here, so you can click and find our date. Here is my reference. As I told you, Asia Pacific Science Education. This one is open access journal, so you can find all our papers, most of papers from this journal. Okay, thank you.
Okay, thank you so much, Dr. Chu. That was a very insightful presentation about your intercultural STEAM program and the importance of this approach for increasing equitable opportunities for students to learn science, and some of the exciting results you are getting, as well as some of the challenges for teachers in implementing this approach. There are a couple of questions already in the chat. We'll take a couple of questions now and then save a couple for the panel to be sure that we have time. Oops, my video is off, sorry. So we have a question for you up in the chat about the relationship between science technology approach, STS, STEM, and STEAM, and how this looks in chemistry learning, and if every component has to be fulfilled to be actually implementing this approach.
I think that's a really good question. I had this similar question many times. We are not really clear about how many components we integrate for one topic. We want to integrate various perspectives. Maybe sometimes it could be science, art, mathematics. It could be science and technology, science and engineering. But the main aim of STEAM is for students to use various ideas, perspectives within integrated situation. It's not about like how many subjects, what subjects we are integrating.
Great, thank you. We have a couple of hands up. So I see Muhammad, if you want to unmute yourself and share your question.
Okay, thank you, Ms. Rachel, Ms. Chu. Good morning. I'm Muhammad Hamzah Syawal. Can you hear me?
Yes.
Okay. I'm a student, a postgraduate student in UNM, and actually I work as teacher in high school in West Sulawesi in Indonesia. I do actually believe, and I personally love the STEAM approach for science, especially in science. STEAM is a very good approach since it collaborates 5 disciplines into one system. But in reality, we have some challenge in our educational system in Indonesia. Firstly, art itself is an underrated discipline in Indonesia. Love it or hate it, we just see art as an underrated discipline. We enjoy art, but somehow some people don't give the credit it's deserved. And the second is the syntaxes or the learning steps for STEAM is relatively hard to be integrated in Indonesia curriculum. Here, we, the teacher, are obligated to have a rigid steps. We have the rigid steps, which is not compatible to STEAM. We do have the obligation to make rigid steps. In Indonesia, we call it study plan or RPP, but it's actually a rigid system for us. And the last, that it's hard, relatively hard to be implemented, the STEAM, for students with challenge. Like first, the students with social challenge. Some students is not good at social skills, and they don't do well in STEAM as well. The second is the student with not the same cognitive level. It's hard to make them work in the teamwork in STEAM. And the third is the student with attitude. We do have students with attitude, and it's hard to make them to work in the STEAM system. So my question is, how do we apply the STEAM system, the STEAM approach in this kind of condition? Thank you.
Thank you. So it sounds like his question is really about some of the challenges you posed are the same challenges in Indonesia, that arts education is underrated and not very valued. And also that it's hard to integrate into the curriculum because of other obligations. And also that students sometimes don't know how to work together in groups collaboratively to do some of these STEAM projects. And so what recommendations do you have to overcome some of those challenges?
I think in Indonesian curriculum is obvious, I'm not sure, obviously similar to Korean curriculum, very rigid and subject-oriented, achievement-based, right? So I cannot say about policy, but I can give you some example. Korea has created 10% curriculum time for this kind of STEAM approach. So 10% curriculum time, it doesn't matter any subject, teachers helping each other, they develop program together, then somehow they pick the learning outcomes from each subject and they run the program like what I did. So it could be home economics, but connected to science like some chemical knowledge. And then they try to solve the home economics subject curriculum issues. However, my program is more science focused. I wanted to focus on science concept and integrate other things. Maybe that was the first stage in Korean's team, but they are moving towards more ahead. So they have really STEAM, sometimes science is outside of elements. And then key elements could be geology or social study or art. And so there are many ways. If schools really want to have those programs to raise Indonesian student 21st century skills, like creative thinking or those things, I think this integrative approach is very powerful. And the other thing, you mentioned that arts was underestimated, but I mentioned in our program, arts means literature, creative art, but I also mentioned socio-cultural events, anything that something connected to their culture in everyday life. I think in science classroom, teachers using already those everyday culture or social cultural practice for science lessons, but not like me. I had this social cultural component or art component, for example. I have here science lessons. Every lesson I wanted to integrate. They talk about it at the beginning, pose questions, do activity, discuss about the first question again. So every lesson they talk about what they explored. But teachers are actually doing those culture or everyday social cultural practice examples. They already integrate in science to encourage, to raise their interest at the beginning of the science lesson. I think that's really common. So, but you just have to change your mind. I don't want to, this program, we don't want to use arts as just for fun. We want to use arts for students to develop their concepts, improve their attitudes, motivations, all those things. About the teamwork, yes, I understand that some students will not like teamwork, but they will learn each other. For example, in the group, when we pose a group, there is some student who talk always, others not. But I found out, I told you STEAM could be equity of delivering science. When we have this teamwork, the student who didn't like science, they start to talk because there are arts component, drawing component, some climate change component, social issues. So I think even though some students don't like teamwork, we should always include it in the classroom for equity purpose. I want all students who, can enjoy science. If we emphasize only STEM, only science from textbook, I think 50% of students in the classroom, they will not really enjoy the science. And
okay, thank you so much, Dr. Chu. There was very many good questions, and I think as we think about your answer, there was another question in the chat about how this applies to higher ed, and I think some of your response to that question helps to think about how in higher ed you can also apply to real world learning, have some exploration of activities before you do explanation, so that students can engage in this kind of learning. And I see there are still hands up, but if you can save your questions for the panel or add them to the chat, we can save them for that point so that we can invite our next speaker to proceed. Thank you so much.
yeah, thank you so much.
So our next speaker is Dr. S. Ravindran, and he had started his career at Swiss Cottage Secondary School teaching physics and mathematics. He has served in the Educational Technology Division as an IT instructor and Educational Technology Officer. He has obtained his master's in education technology from the University of Southern Queensland and Doctor of Education from the University of Western Australia. He presently serves the teaching fraternity as a master teacher with the Academy of Singapore Teachers, where they explore and learn together for professional excellence. And so he is here today to share with us about action research insights from a school-based PD approach in enhancing PCK of secondary physics teachers in Singapore. So welcome, and I will turn it over to Dr. S. Ravindran.
Thank you, Dr. Rachel. Thank you, Hayun, and not sure whether Prof. Tregas is also in this session also, but thanks to Prof. Tregas also for his sharing earlier on. Learn so much every time I hear him. And selamat pagi semuanya. Good morning, everyone. Really thankful for this opportunity to share. And I'd like to maybe start off by the way, my slides, is it viewable by everyone? Okay, great. All right, so I'd like to focus on some of the insights that myself and my team of colleagues back in the Academy of Singapore Teachers in Singapore, what we've done with our colleagues in schools, so that we can provide some action research insights, all right, on this approach that we actually applied, tried out, explored, and kind of learned from about enhancing the PCK, or the pedagogical content knowledge. I'll explain a bit about that for those who are not too familiar with the term. The PCK of our secondary physics teachers in Singapore. So maybe I'll start off by just telling a bit about my work in the academy. All right, I and my fellow colleagues are basically teacher educators back in the Ministry of Education in Singapore, and we work with teachers especially in particular physics teachers, in providing and conducting courses, programs, workshops, and even facilitating learning communities with these physics teachers and teacher leaders actually also in the pedagogy of teaching the subject of physics. So in other words, it's about how can we effectively teach the subject of physics. And one of our exploration, right, learning about what is the most effective way in which we can do this, in which teachers can develop or enhance their practice, is one particular development project that was funded by the ministry, that the team of us, four physics teacher educators that work with two separate schools with two separate professional learning teams to explore the conduct of a particular approach in professional development, all right, with the teachers, to see how they can improve their planning of a particular unit of lesson, a particular topic, how they can then carry it out, implement it, and how they can benefit from the reflection that they do on this whole experience. And that's where I think the action research comes in, right? In terms of the learning that comes out of this whole process of planning, implementing, and reflecting. So I'm gonna go into that, and hopefully that will be useful for all of you. So this project, all right, if I can just touch a bit about this project that's funded by the ministry that we did way back in 2017 to about 2020, actually has this simple aim. It's not particularly an academic research project, but rather it's a development project where we explored the use of a particular PD approach that we think would be effective in enhancing, in improving the practice of teachers in terms of their pedagogical content knowledge, in particular secondary physics teachers. And actually this approach also focuses on specific topics, as I would explain later, right, why that would be the case, because of this very topic specific PCK that we are talking about. So let me go into that. So, but before I start, maybe let's come to some kind of a common understanding of what PCK is about, what pedagogical content knowledge is. I'm sure most of you are familiar with it, but for a common understanding of this, as I use this term subsequently, right? let's understand that PCK is really about this special knowledge that teachers have, all right, as teachers, that that allows them to transform whatever content knowledge that they want to teach into a form. And as what Prof. Triggers explained earlier on, right, the multiple representation, which is such an important part, because it is through these multiple representations that we try to help our learners, our students, understand the content of physics that we want to teach them. And so that's what we're really interested in. We want to know how we can actually capture this pedagogical content knowledge of especially our expert teachers, and in that process then learn and share this knowledge with others, so that they can enhance their own PCK. And we're using this simple model that was started by Prof. Lee Schumann, the picture of which you're seeing now. He's the father of pedagogical content knowledge, and he introduced this construct, right, of PCK, which is actually, if you want to imagine it, is the sweet spot where all teachers, if they draw from their subject content knowledge, in this case if it's physics, and if they consider the context in which they're in, the classroom context, the environment, the facilities, the resources they have, and if they draw from their pedagogical knowledge that they have learned probably from their teaching college, from their own reading, from research, so that sweet spot, in other words, that point where all this knowledge comes together and provide the teacher with that right action in terms of teaching, or right practice in terms of teaching, that helps the students to really understand, enjoy, and learn, and be engaged in the learning. And that's what we're looking for. What's that PCK? How do we enhance it in our teachers? So maybe a bit about the background of our project. So as a team of teacher educators back in the Academy of Singapore Teachers, we actually use PCK as a basis for which we want to try and improve the teaching of physics in the classroom. And we were following the research work on PCK, starting from Lee Schumann way back in 1987, down to Professor John Logren, actually, in Australia, from the, let me see, Monash University. Yeah, I almost forgot that. All right, and John Logren and his team actually came out with this tools which we are using. Again, I'll tell you more about it a bit later. The core and the paper. Way back in 2015, we started using that also. And in 2016, we learned about this new understanding of PCK from the Gass-Newsom model of professional teachers' knowledge. And this actually kind of shaped the PD approach that we actually we tried out and we are very convinced about. And this is what I'm going to be sharing about. All right, so let me just move on. And so, of course, from this research work of these researchers, we draw on the implications to PD, and that's why we actually consider them in our PD approach. Now, if I can just highlight this particular model from Gass-Newsom, which we really draw inspiration from and also makes full use of in terms of our approach. Let me just try and see whether I can zoom in a bit. This model actually starts off by considering where our teachers' knowledge comes from, right? Where are the bases, teacher knowledge bases? And basically this would come from, the teaching college that we would have gone through as a teacher, or maybe from our own reading, our own learning, our attending of workshops and all that. And from there, right, actually when we talk about teachers planning to conduct lesson, they then focus in on that specific topic that they're going to teach, and what is that knowledge that they can draw from that in terms of the strategies that they have learned, or they have tried out, or they have been exposed to, or maybe they attend workshop and learn about. And they also find out how are they able to represent, and that's why again multiple representation is so important, because in particular physics, right, you cannot learn a concept most of the time just by a particular representation. You need a few representations to fully understand and appreciate what the concept is about. And also draws from the teacher's understanding of their students, of their profile, of their learning preferences, and some of the practices and habits of mind that they possess. And with this, right, this knowledge, then you find that when the teachers try to enact their lesson, to carry out their lesson, although they may plan all these things based on their professional knowledge, but there is this thing which in this model highlights that there is this amplifier or filter within all teachers that kind of decide whether are you going to carry out what you plan, or are you going to respond to how the students react in the classroom when you teach. And so this is an amplifier or a filter, because some of the things you may have planned for example, I plan to do group work in this lesson. But then when I go into the classroom and I find my students are all not in that state of mind to do group work, I immediately switch to, frontal teaching. Now, when that happens, right, what has happened is there has been a filter that kind of blocked you from doing group work because of the context. But on the other hand, you may have also amplifiers where a teacher suddenly finds that students are in a mood for role play, and the teacher suddenly decides, okay, I'm going to do role play because I think that's going to help the students understand the concept of, for example, resistance. Therefore, may change because of this. And these are all dependent on teachers' belief, their orientation towards teaching, and the context, of course. And what happens is in the classroom, when the teacher conducts whatever they do, that becomes what is called their personal PCK. And so Gess Newman introduced this idea of what is personal PCK. So every teacher have their own personal PCK because they have their own belief, their own orientation. And this also dependent on the classroom context. But having conducted the lesson as how the teacher would conduct, it doesn't mean that the students would all learn from it, because again, whether the students understand your lesson or not depends also on a set of amplifiers and filters that the students themselves possess. So certain students may have certain beliefs, certain prior knowledge, or certain habits or behaviors, and that would affect how they actually see what you have taught them and whether they understand what you've taught them or whether they agree with what you've taught them. So the student outcomes as a result of that is varied. So sometimes you may have students who are not interested, sometimes you may have students who understands and are motivated, sometimes you have students who cannot follow what you. So that student outcome is an important aspect of this whole process of classroom learning. So if I can maybe draw a simplified model of this and help you to understand what is so important about this model. So you have the teacher professional knowledge base to begin with, which all teachers would have. And then when you're planning to teach a topic, you would have certain specific topic knowledge. And as you enact the classroom teaching, you find that you have your own beliefs and orientations that would affect whether you amplify or whether it filters or blocks, all right, some of the things you want to do in your planning. And this would feed back to your own personal professional knowledge, all right, so that subsequently in future lesson, when you plan, you would think again, whether is this something I want to do or not based on the practice. And apart from the practice, right, when you see the students respond or react to how you have taught, all right, that also has an impact on your own knowledge. And more importantly, it also has an impact on your classroom practice. And I want to, in particular, right, highlight this particular link, which is the student outcomes actually will have an impact on what your beliefs and orientations are. Because if you find that something you've done, group work, it works because students all are engaged, they're all learning things and they are responding and they are, happy about the learning and joyful in their learning, then it will feed back to you and your belief will be, yes, group work works, it helps the students. And subsequently, your practice would probably involve your making use of group work. And so this is an important aspect, and this is an important point to note, because the PD approach that we are considering actually requires the teachers to take note of this and to build on this. And this is how we go about doing it. All right. So let me just move on to the next slide. Okay, so this approach, we call it the three-stage professional development approach. So drawing from this model, the Gess Newson model that I shared earlier on, we actually broke up this PD approach into 3 stages. And maybe at this point, I just digress a bit. So for those of us, those of you who are teacher educators planning to work with teachers and all that, right? Just keep in mind that it's good to have a certain kind of a model or approach to base on, so that you can use that to focus on your different aspects of your professional development. For example, if you're concerned with helping your teachers to develop their teaching. So coming back to this PD approach, right? So what happens is we consider 3 stages. The first stage is when we get the teachers to do the planning and development of their lesson for a particular topic in terms of a unit of lesson, for example. And this is where we make use of a particular tool called CORE, or short for Content Representation, which was introduced by Professor John Logren, and I'll tell a bit more about that in a moment. So this CORE tool really is an important part of this approach because it actually is made use of in the planning stage for the teachers to actually develop the lesson, and the process actually develop their own knowledge of this lesson planning skills and all that. So let me come to that later on. The second stage is when the teacher is carrying out the lesson, right, in the classroom. And in this process, right, the implementation part, this is an important part because the feedback that they can get from this, or if they can capture their thoughts on this, right, and that's where the paper tool, which actually is a tool again developed by Professor John Logren and his team, helps to capture the teacher's thinking and reasoning in the process of carrying out that particular practice in the classroom. Now, earlier on I said, right, a lot of time the teachers may plan a certain lesson plan, but when they carry it out, they may change their practice. And this is where the teachers, if they can capture why did they change, what was their thinking, what was their concern, that would help them to understand, or help us to understand what is actually the pedagogical content knowledge that the teacher has, all right? Now, the third stage is an important stage because we all know how important reflection is, and this is part of the refinement because at the end of this process, the 3 stages, it's important for the team of teachers to actually come together and reflect on what they have gone through in the process of conducting this lesson and how they can refine it and improve on it in a subsequent lesson or in the following year if they're doing the same lesson again. All right. And this is drawn from evidences of the students' learning also, and early on. The students' outcome is so important because what the teacher observed in the classroom with the students would actually influence how they follow up. Okay, so with these 3 stages, right, we actually conducted the project with the 2 schools. But before we go to that, right, maybe if you're wondering, so how does this PD model fit into our work with the teachers and teacher leaders? All right. Now, back in AST, we have a certain instructional model that we follow in terms of all our workshops and courses. Normally, we will base it on this 5C PD instructional model, which basically aims at this outcome of ensuring some kind of professional growth in the teachers, which is in the form of gain in knowledge or their belief in the PD content, or even some possible changes in the instructional practice so that they can try something more effective and more innovative. And it's all based on theories that are drawn from research, whether it's conceptual change theory, whether it's about sustained and effective PD, whether it's about adult learning principles, or even about the Schulman's pedagogical reasoning and action. All right. So based on this, what we've got is this 5C. All right. Normally we will implement, or rather consider in our courses or workshops, where we first begin with getting the teachers to be interested, to be curious about what they want to learn. Then we move on to getting them to understand in the process of presenting whatever they need to learn. And then we need to convince, because I think the teachers will not buy in on whatever you are sharing with them unless they're convinced. And subsequently, right, the last 2 is a bit more challenging, to get the teachers to contextualize and to consolidate their learning back in their school. And this normally is harder because we would normally give a time gap for the teachers to try out and then come back at a subsequent session and then share their learning. Now, this 3-stage PD approach comes in useful because there are some teachers who are keen and interested to actually have us work with them for this contextualization and consolidation part. And this is where we bring in the 3-stage PD approach to the school. We work with the teachers and the teacher leaders in the school, implement this, and then in the process, we all learn from it. So that's where this PD approach comes in. Okay, maybe a bit about the details, and I think I'm running out of time, but let me just give you some of the details about the project so that you understand the context. So this project involving the 3-stage PD approach was carried out with 2 mainstream secondary schools in Singapore. And these physics teachers in these schools, actually they form professional learning teams. And here in Singapore, in schools, the formation of professional learning teams or professional learning communities in schools are very much encouraged. In fact, time is also given for school teachers to actually find time in their curriculum to actually meet up and work on this, whatever is their project at a protected curriculum time during the week. Each week they have probably about 1 hour to meet and to actually work on this as a team. And so we made use of this and we work with these two teams of school physics teachers in the schools. Now, this collaboration with them actually is a participatory practitioner kind of a research, and that's why we see it as an action research when we collaborate with these teachers and teachers leaders in these PLTs, all right, or professional learning teams. Now, what we also do is that we have 2 iterations. It's a design-based model. So what happens is we repeat this cycle twice, and why it's important to do that is because after the first cycle, when they reflect and they refine, that's when you want to see how the teachers respond and think about the next time that they do the same lesson again. And so this 2 iterations is an important process or part of the process in this professional development approach. What we did also as teacher educators and also as practitioner researchers, we collected data, mainly qualitative, but also quantitative in the form of questionnaires, team discussions, lesson observations, written reflections, interviews, and even artifacts from their students' work. We even video recorded some of their lessons so that we can go through them and kind of analyze them to understand better their thinking in their lessons. So the data coded and analyzed so that we get an insight into the teachers' knowledge, their beliefs, and the practices. And this is what we are interested in. We were actually exploring this so that we can understand this better and see how this 3-stage PE approach works, whether it's an effective way and whether we can continue to work on it with the teachers. And these findings from the 2 schools, actually what we did was, because we were doing it at 2 separate schools, we then do a cross comparison of the case studies. We consider each of them as case studies. And we came up with certain assertions, all right, about what this PD approach requires, all right, so that there can be a change in the teacher's thinking and practice. And so those assertions I'll be sharing with you in a moment. Okay, so just a quick run through of this whole project thing. There are 2 cycles. So year 1, basically, right, we divided it into 3 parts of the year. And the initial stage was to plan for a lesson that was coming up in the stage 2. And then in the implementation stage, there were lessons enacted, there were videos recorded of the lesson. The stage 3 was when the whole group come back again to do some kind of a reflection. And we also conducted interviews and to understand, focus group discussion to understand what the teachers gone through. And in the year 2, the second round, the second cycle, similar stages were gone through. And similarly, we collected data in each of these stages. Now, if again, I mentioned core and paper, right? So now I just touch a bit about what core is and how important it is. The content representation, for those of you who are not familiar, those who are familiar, right, you will probably understand John Logren's work. And actually the core is just a way of, or if you want to think of it as a template, we call it a tool more, because it allows the teachers as a group, as a team, when they come together, right? And this team normally is about 4 or 5 teachers coming together and looking at what, for the topic that they're teaching, what are the key content ideas? What are the alternative conceptions students may have? What are the ways in which you can test whether they understand or not? So all these questions are brought up through this content representation tool and discussed, and so that the teacher have a better understanding of the lesson that they're planning for and what they need to do to teach. And this is all captured in what is called 8 prompts. And I'll show you in a moment what these 8 prompts are. But bear in mind that this core is not, or we in fact remind the teachers when we go through with them on this, it's not a prescription to tell them this is how I'm going to teach, or this is the best way to teach. It is not. It is just a group coming together, drawing from the experience, drawing from literature, drawing from the knowledge and their learning. What would be some ways in which we can teach this topic more effectively? And then they kind of discuss with one another and come up with a certain plan. And it is also not intended that, that every group that come up with a core on the same topic would all have the same core. It is not. So let me now just show you what the core is. The core, it looks something like this, all right? 8 prompts. And for that topic that is to be taught, the team will come up with what are the big ideas that need to be taught. In our case, we have modified it to call it teaching ideas. So we were interested in what are the teaching ideas that the teachers need to get across to the student. And as you go through these 8 prompts, you realize something, right? And let me just highlight. First of all, you find that the first 3 prompts about what you intend the students to learn, why is it important for students to know this, and what else you know about this idea, you may not want the students to know yet because you otherwise confuse them. So this set of prompts, right, when the teachers discuss in their planning and think about it and look at their topic they're teaching and the concept that they need to teach, actually is the process of unpacking their subject content knowledge. And the next three prompts actually, where they look at difficulties of the students, the knowledge the students thinking have that will influence the teaching, and other factors that may influence the teaching, actually is the contextual knowledge. What is the situation that the students are in that they're going to be learning about this? And the third and last one actually is about unpacking their pedagogical knowledge. In other words, it's about what are the procedures in which you're going to carry out to teach, and what are the specific ways in which you can find out whether the students have understood or is it they're confused. So that one is about the general pedagogical knowledge. Now, if you look at this tree, you will understand why this core actually helps us to capture an aspect of the teacher's PCK, because it touches on all the three knowledge the domains that you draw from when we talk about pedagogical content knowledge. So examples are given here. I mean, not intended for you to look at the specific one, but just to highlight to you that actually what we have here are teaching ideas rather than big ideas. So we have considered for a certain topic like electricity, we unpacked it into what are the main ideas that the students need to cover. And then we get the teachers in their team to think about why is it important for their students to know this. And it need not necessarily fill up all the boxes. So it is meant for them to fill up which are the relevant. For example, the difficulties, many of the teachers know from their experience, from literature, what are the difficulties for this topic, electricity, right, that the students will encounter. So they put it down and they work on that, and then they consider how then can we find ways in which we can teach this effectively. So that is the intention of the core. Now, let me quickly move on. Now, the data collection, I won't go into too much detail of this, but in each of the stage, we collected quite an amount of data so that it can help us understand, all right, the teacher's experience and their understanding and their thinking. So, so things like the core represented data that we collected, their lesson materials, their notes at the meeting, in what they discussed on. In stage 2, when they implemented, we actually collected data on their, from observation notes. Some classes, we did a pre and post-test questionnaire where the teacher wants it so that they can understand whether the students understood certain topics. We also did post-lesson meeting notes and so on. Stage 3, where the groups come together, was where we actually captured their reflection notes in the meetings. And also, we actually got them to discuss what we call the papers. And these papers, it's a long-term, actually, we spell it out, is pedagogical and professional experience repertoire. Okay, these are actually like reflection notes that individual teachers actually are supposed to create. But I think we all understand, right? I think if we need to come up with some kind of notes on what we have done in the classroom, we'll find that a lot of time teachers find it difficult to do that because they don't have the time and they don't want to spend so much time thinking about what they have. But if teachers were to do this, right, it's a very useful account that they can capture. Oops, sorry, let me go back to this. Okay. That on the specific lesson that they have conducted, and it actually gives an insight onto why they do what they do in the classroom. So like what I said earlier on, they may have planned something, but they conducted something else. So that is this paper actually helps to capture that. And this can be a aha moment where suddenly they realize by doing role playing, the students understand, which they didn't plan to do actually. And so there's an aha moment which if they capture it, it can be made use of in subsequent lessons. So this I think, or it could be a difficulty. They tried something, it didn't work. Now they try and reflect, why is it that it didn't work? Was it the way I delivered, or was it the students were not ready? And this came in the form of a simple template that we created. So this was to capture, I just give you an example. This was to capture, for example, what were the important concepts that they were teaching. So it draws from the core also, but at the same time, more importantly, actually, is the synopsis of the practice. So it's actually a description of the learning sequence and the teacher's actions and the reason why and what. So it's to get them to reflect and think through. All right. So other things that I just want to highlight here without going too much into detail is that we made use of a number of frameworks, one of which is Schumann's 6 stages in the process of reasoning action, to help us to kind of capture what was going on when we look at all the data, right, in terms of what the teachers were doing in the classroom, what were they planning, what were they discussing, what were they reflecting. We actually were able to capture for each stage, right, the different aspects of this process of pedagogical reasoning and action that Shulman talks about for PCK. So we come to understand about the comprehension, about the transformation of what they want to teach, how they transformed it into the forms that they want, the multiple representations. When they were carrying out the instructions that they delivered, how did they evaluate whether the students understood? The reflection part was there new comprehension gained from this whole process, and how was the refinement, right? So all these were captured through this particular framework to help us understand and analyze. We also use Mortimer and Scott's analytical framework for science lesson, especially when we're looking at the videos of the lesson. And this helps us to kind of view the lesson in terms of episodes. And episodes would help us understand what is the purpose that the teacher was doing in this part of the lesson, and what was the content that was being delivered, and how was the teacher trying to communicate. Was the teacher very authoritative or very interactive, very dialogic? And so this was captured to help us understand, right, the lesson that was being delivered. And also what was the pattern of discourse in their teacher's actions, right? And what was the intervention that the teacher brought in during the lesson. So all this helped us to understand the lesson better. And what happened was, from the two case studies, right, the two different schools, we were able to draw out the learnings. But at the same time, please understand that as we go through this process, right, the intention with the teachers is to help them to actually improve their lesson. So there are, in a sense, you can think of it as two levels of action research. One was where the teacher was trying to find out what was the best way in which they can improve their teaching through this whole team effort. The second is that we were looking at this whole process to understand whether the professional development approach, this three-stage approach, was really helping them to do that. So it was two levels of action research in that sense, and which we captured with the data that we had. So in terms of the case studies, the two case studies, the findings that were specific to the topic, for example, for electricity, for energy, there were a few insights gained that our teams of teacher educators kind of were able to analyze from the findings. And so it was captured in this form. And what we did was we actually did a cross comparison of these two to try to further understand what are the assertions to this PD approach that will be useful for subsequent consideration of this three-stage PD. And so from these insights, actually are these assertions on this project, which I think I hope be useful action research insights for all of you planning to work with the schools and working with the teachers in any kind of a project to help them to improve in their teaching. And so the assertions that we kind of learned from this process is that, one, the professional learning team, right, they definitely found the content representation tool, and we felt the content representation tool really helped them to really dive deeper into their understanding of the key ideas that they want to teach their students. And in that process, right, understand how to get it across to the students meaningfully, so that the students really understand it and not just learn for exams. And so on that note, right, actually the approach actually requires, in that team of teachers, right, a certain spirit of exploration. They must be willing to try out something and in a way throw away some of the ideas they may have and innovate and try out things and find out for themselves. Because don't forget, the Jess-Newsom model says that the student outcomes, what happens when they see the students, react to the lesson, that will actually affect how they're going to subsequently think about how they should teach. And so that exploration and innovation and trying out, the dare to do spirit needs to be there. Now, the other point is that we also realized, and the team actually as a whole also realized, that when they were thinking about why am I teaching this and why am I trying to do in getting this topic across to the student, they realized that actually although they are preparing students for exams, and I think Hayun mentioned earlier on, our countries, most of our countries are focusing on assessment, but they also realize that there is this higher aim in which I'm teaching my students, and I want them to learn something that will help them in their life. So learning to succeed in life, how can I draw that out in the process of the learning, and how do I put that into the learning? So that became something also an important part of this whole process. And we realized the PLT, right? Earlier on I mentioned that there's time given to teachers in the school to actually work on this as a team, to learn together. It's really a crucial platform, and we are glad that we've got it in our schools that provides the teachers with this opportunity to come together every week to go through this process and learn. And so this three-stage PD approach fits in nicely to help them use that time to develop themselves. Last and not least of all, we realize, and the team themselves also realize, that this three-stage PD approach needs all the members to actually actively participate and not just be passive members just listening to the others, but to actively participate, give their ideas, their understanding, their experience, and be open to learn, to share with one another, to find out from one another, to go into each other's classroom, to see what they're doing, and to discuss and provide feedback. In that process, then only this three-stage PD actually would work. I hope I've not taken more than the time that I've been given, but I think with that, just one more thing, all right, maybe from the perspective of the teacher educators or researchers who are doing this, the learning points that has been gathered as far as our team of teacher educators are concerned, is we found that, considering useful frameworks for discussing the PD and to talk about the PD to teachers is an important part, so that teachers understand what they're going through in a sense. And so the Logren's core tool and their paper tool and Schulman's 6 stages help us to frame whatever we are seeing and hearing from the teachers, and to help us understand, and the process help the teachers enhance their own PCK. Even Mortimer and Scott's analytical framework for the science lessons is a very useful tool, especially when you're looking at videos, right, to try and understand the episodes. Secondly, to adopt this practitioner researcher stance is both a challenge as well as a necessary thing, we felt, because when we started off, we thought we would play the role of researcher and let the teachers do the work. But then we realized at some point, because we are ourselves teacher educators, we also became part of the team, and that's why this idea of practitioner researcher is actually an important part. So maybe the question of where do we draw the line, maybe we can discuss that later. But it was an important part because in the whole process we learned, right? And last and not least, that the time and context constraint, right, as evident in anything that we do in schools, I think most, if not all of us know, is we try to fit our project in such a way that there's minimal disruption to the school program. We don't want to interfere with the school program, but because of that, there are some things that we couldn't do. For example, we wanted all teachers in the team to actually be able to view each other's lesson and give feedback and bring that to the table in our discussion, in the reflection. That couldn't really happen properly, or we wish we could do more for that. So that aspect also was really a challenge for us. So with that, I thank you everyone. Terima kasih, and I hope it has been a useful sharing, and I look forward to hearing questions from you all in the panel discussion. Thank you very much.
Great. Thank you so much for your thoughtful and astute presentation about your PD approach. It has many similarities to the work that I do at the Institute for School Partnership at WashU, so I very much appreciated it. In thinking about PD models and how you can be practical for teacher educators, but also serve your role as a researcher to help improve teaching practices and student outcomes ultimately. Your practical examples provided a great jumping off point for our workshop participants to consider how they might use action research as a way within their own classrooms or as teacher educators to help think about supporting improving classroom practice. We, as we did for all speakers, can take a couple of questions for you individually, and then we can move to the panel. I see one hand up, which is Abdul Rahman.
Yep, I'm here.
Go ahead with your question, please.
Okay, thank you. Is it clear enough? Just check my sound.
Yes, we can hear you well.
Okay, thank you. Yep. So I'm coming from Dr. Rafendra. I'm coming from what's that? My recent interest is also in teacher professional development, and then school-based PD is one of the approach that is maybe strategic for some circumstance, from some context, because early in your presentation you said that it's contextual. So So if you can share in your research, do you find that like collaborative practices of teachers in particular schools affecting the implementation of this kind of PD? Okay, whatever the content it is. According to the theory, for example, I think you are familiar enough with Guskey and Decimal model that the teachers believe can change either first they see change on improvement on the students, meaning that there's evidence that what they are learning is useful, is benefited their students, and then after that they can take up the practice that is aimed in the project. And then the second one, do you find any like things like the feeling of the teachers that this is something done to us? Yeah, the project is something done for us. This actually is not ours. So how do you think when, for example, researchers is for example trying to do the same research, and then how to manage this, for example, let's say rejection, okay, because something external to them coming to, for example, to preach and then to offer something that I don't know, maybe they think that this is the things that we need actually according to our context. Thank you very much, Desi.
Thank you, Mr. Abdul Rahman, for the question. There are two questions here, so let me just try to address one at a time. The first one about whether the collaborative practices of the different school teachers, right, whether that would kind of affect the PD and all that. Yes, definitely. If you're talking about collaborative practices in terms of how the teams of teachers actually in the school are able to work together to plan for lesson, and whether they feel comfortable with that, it is also part of the dependent on the school's culture, and of course that department, the science department in particular, that kind of help to facilitate this kind of teamwork and all that. So that is why this idea of practitioner researcher is so important, because when we come in, maybe this can also cover the second question in terms of whether do they see us as trying to do something to them, in trying to get something out of them, I suppose, in getting them to do this. Because when we come in as practitioner researcher, and because of our roles as master teachers, they recognize us as teacher educators working alongside with them as part of this community of physics teachers. They understand where we come from when we come in to work with them, to share with them, and to work alongside them, to try and learn together. So this is a very important part, because as practitioner researcher, we need to make the teachers and teacher leaders in those groups understand that we are not there to, that's why this whole thing is a project, actually. It's not really a research. So it's a project where we work with them, to learn together with them, and then to discover, right, what are effective ways. But in the process, because we are experienced in our subject area, we sometimes share ideas and resources and even tools with them, so that they can also try them out. So it is so important, first of all, that they feel comfortable with us, and that's why we have weekly meetings with them from the start of the project, to get to know them, to work with them, to be in the classroom with them when they're conducting, and sometimes we even do some of the lesson parts which involve certain maybe resources that they're not familiar with, so that they can also see how we model it. So in that process, they feel more comfortable, they feel more open. Actually, it is very true. At the start, the first cycle, usually the teachers may be a bit hesitant. But as we move along and they know that we are also in the process of learning together with them, they are more open and they're more willing to actively participate. And that's where we realize the active participation of the participants are very, very important for this whole approach to work. So I think that need to be considered. Yes, they would have different culture in the way they work with people in the team, but this is where we need to come in as a practitioner researcher to actually allay their fears about what we're trying to do here. We're also in the process of learning together with them, and in the process, everyone benefits, all right, including other teachers in the fraternity. I hope that answers your question, Mr. Abdul Rahman.
Okay, that's it. Thank you for the insight and thank you for the answer.
Thank you.
Thank you very much. I think we can take one more question from Farizi.
Well, thank you very much, Dr. Rachel.
Thank you.
Okay, for Dr. Ravindran.
Yeah, call me Ravi. It's okay, Ravi.
I have one own question in here about the pedagogical content knowledge increase maybe. In here, I want to see your own opinion about can the teacher in the little village, I see in here Indonesia very hard to increase their experience to teach their student in little village. Is PD approach still can be using to increase our PCK teachers in a school little village using that approach, which is that schools and class condition didn't have any technologies and facilities more complete to make and helping the teachers to increase their content knowledge to teaching their students. Maybe that's my question. Thank you.
Thank you very much, Mr. Farizi. Actually, so far, when I shared about the approach, I never mentioned the need to use any particular what you call it, equipment or tools or technology even. What is required is actually getting teachers to come together to actually hear ideas from one another, to work with one another. So whether you're teaching in a village, whether you're teaching in a city, whether you're teaching online also, it doesn't matter, because what is more important is what do you bring to the classroom in terms of how you're going to approach the teaching. Whether you're teaching to prepare them for exams, whether you're teaching to get them to just remember the facts, or are you teaching for them to understand and have a deeper understanding of the concept that you're teaching. And that one doesn't require any kind of resources in a sense. You can use every day, like what Dr. Chu earlier on talked about, for STEAM or STEM. You can draw from everyday things around the students or around their life to use as examples to understand certain concepts. In particular, physics, if I'm talking about physics in particular, you can draw from things around them to help them understand certain concepts. And so the teacher needs to draw from this and draw from the experience, whether you're in a village or whether you're in a city, right? These are things that you probably have come across, your students would have come across, and you can use that to help them to understand. But what is required is this. This stage requires the teachers to come together, hear each other out, try out certain ideas, come back to the table, and then discuss what has happened. And if the student outcome is positive, it's going to help enhance their PCK. And that's how you're going to grow your PCK. So it doesn't matter what is the environment. Hope that answers, Mr. Farizi.
Thank you very much. I think that's a clear answer.
Thank you.
Wow, thank you so much, Dr. Ravindran, for that presentation. We are going to now start the panel discussion, so bringing back all three of our speakers. And as we do that, just as we think about the presenters today sharing important insights from their research, providing strategies that can be used to improve science teacher and student science learning, Dr. Trigas shared multiple representations and the role of this in developing student understanding of science, and shared how this might appear in biology, physics, and chemistry, emphasizing that the time we take to develop this deeper understanding up front can support student learning in the future. Dr. Chu added on to Dr. Trigas's keynote, providing a specific example of modules developed to include multiple modes of representation, but to integrate the arts in ways that STEAM content can be used as a starting point for guiding student inquiry, dialogue, and critical creative thinking, and help remove limitations which students may feel when participating in traditional STEM. From a participatory research approach, Dr. Ravindran helped us begin to think about what action research could look like, by sharing a framework and approach that can be used to support teachers to enhance PCK and improve their teaching practice, focused on practitioners and researchers learning together, but also emphasizing, again, the time that it takes and the routines and structures necessary to support that collaborative teacher learning. And so as we invite all of the panelists together, they have posed some questions for us to consider, but also want to open up questions that the audience might have for the panel.
Excuse me, Dr. Reza, may I share the screen?
Yeah. Oh, yes, please.
All
Oh,
right.
yes, please.
All right, here it is. For Professor David Tregus, some questions for consideration. First, how can teachers best achieve their goals of students effectively learning science concept beyond rote learning, sir? For the first question, sir. How can teachers best achieve their goals of students effectively learning science concept beyond rote learning, sir?
Okay, so you asked me that
Okay,
question.
so you asked me that question.
And
Yes, sir.
And you asked me to answer that question.
So the issue
The issue is
to realize that learning in one domain, like listening to a lecture and remembering is not an effective way for deeper learning. It's much better if you have other ways to learn as well as in this case I'm talking about listening. So I mean a very simple way is to engage students in some group work. And Dr. Ravindran mentioned that, and so did Dr. Chu. In my case, I would say that whatever the topic is being discussed, you ask students some questions about the topic. And you'll find some students I've got no idea what's being discussed. And the other students will help them. And it doesn't need to take a lot of time. Can I tell you, many of my colleagues in the School of Chemistry here at Curtin University teach like that too. They give like a 20-minute presentation. And then they have a 10 or 15-minute discussion that the students have with themselves. And then the students come back with questions. And I don't think it slows down the completing the syllabus. Does that make sense?
Yes, sir. Yes, right. What about the second question, sir? Why do students learn more effectively when science concepts are presented in several modes, sir?
Right, that's the reverse point about question one. If you some students have a preferred mode of learning. So some students learn orally best of all. Some students learn best by reading. Some students learn best by doing. But that's not necessarily the most effective way for every student to maximize their learning. So if they have an opportunity to do something, to read something, to hear something, they're more effective in their learning. This has been one of the problems with the COVID-19 and online learning. So students may well be learning because they're reading and they're listening, but they're not going to be learning as effectively as they would in a classroom. And I think this is well documented already.
Right.
I don't know whether
thank you, sir.
I don't know whether my other colleagues want to comment on that.
All right.
Do you have any evidence of that?
Dr. Ravindran?
If I can just come in, Prof. Tregus, yes. Is that okay, Norwati?
Yeah.
Yes, please.
Yeah, okay. Thank you, Prof. Tregus. Actually, I completely agree with you. And actually, when we work with our physics teachers and all that, as we know, physics, when we learn physics, the representation of the concept that we learn, whether it's about temperature and all that, you can represent it on graphical form, you can represent it in terms of some kind of symbolic representation, or even some kind of simulation. Right. It is so important. It is so important, like what you said earlier on in your presentation, that students need to be exposed to them to understand that they are representing the same thing. Because the problem we encounter is teachers beginning to see
the atoms that they learn
the atoms that they learn in physics different from the atoms that they learn in chemistry.
And that's so funny to us.
And that's so funny to us, but to the students, they you know, when they are chemistry talking about atoms, they are imagining something else compared to what they are atoms. But we, you know, as adults and as learners ourselves, we know that they are actually the same thing, but the students may not. And so this multiple representation and helping the students to see how they are all representing the same thing is so much an important part. Sorry, just to share on that. Yeah.
I have something to share
from
my research in Singapore. When I worked there, I observed the classroom, and one teacher using lateral gesture to explain some particular movements. Then later, when teacher asked the question to students, there are many student candidates who want to answer to the question. Their answers are not perfectly using all scientific but they keep using this hand gestures to answer to the teacher. When teacher use different modes, also it influences student responses. So they can present lots of their ideas into the classroom.
Yep, good point. Yep, good point.
Yes, thank you very much for all the distinguished speakers. I think the third questions already answered by those questions. May I move to yes, Dr. Chu? How will your practice team or STEM innovation in science classrooms, Dr. Chu?
I make this question for Indonesian staff.
I think Dr. Chu's questions were for the audience to consider after her talk. After hearing about STEAM, how they might think about how they could practice some of those principles.
Correct.
All right. Yes. How could be the difficulties or barriers for STEAM or STEM innovation in science classroom? What is the difficulties or barriers, Dr. Chu?
I think as Ravi mentioned in his presentation, he said the teachers' beliefs is very important. If they start to think arts integrated STEM is valuable for to deliver science lesson or level of students, I am sure they will start to study how to extend the science concept into systems, like not only thinking about teaching science concepts, but how this concept is connected to cultural events or other art subjects. But if teacher don't believe it, they will never do. I think so. The most important barriers here teachers' and willingness to practice this innovation in science classrooms rather than curriculum or rather than national policy, those things.
You mentioned, and I heard the Indonesian colleagues bring up. Teacher beliefs matter, but they can be constrained by structures and systems like a very rigid curriculum or assessments that are measuring rote knowledge, not multiple representations, recall, and thinking about how that makes teachers, even if they believe it is very important, nervous to take the risk that it may not pay off for their students on an assessment, in which that is how they are judged, school is judged, or their country is judged in terms of their science ability.
True.
But It was
Yes.
it was very impressive for me when I did Google Scholar search. There was so many papers talk about STEAM in Indonesia in science teaching. During my presentation preparation is first time to explore Indonesian science teachers are so keen to implement STEAM in the classrooms.
Yes, right, Dr. Chu. And then what could be the target outcomes in innovative science classroom? How will you make sure all these outcomes are achieved by the STEAM, the application of STEAM education, Dr. Chu?
Yeah. In Australia, we have those areas of the general capabilities. It's very similar to 21st century skills like intercultural understanding and also understanding of ICT, sustainability. I think those capability rather than knowledge itself, like science, problem-solving skills, those skills are the target outcomes. And it's harder to measure. That's why that's my question. How we could make sure all those capabilities were achieved. But I don't have that answer.
All right. What about the others speakers? How will we make sure all our outcomes are achieved by implementing our innovation, like multiple representations, STEAM, or PCK? How will we make sure that our outcomes are achieved? Any comments? Or maybe from the audience? Maybe through assessment, right, Dr. Chu? Through assessment?
Or Dr. Robbie, I feel like from my perspective, some of the participatory action research, the goal of that is to learn how to take research that may have been around for many years, 1986, and work closely with teachers to figure out how to make it work. And so you ask what does it mean for action research to be relevant? Can action research help make our innovations actually a reality? Can action research be a way to help ensure student outcomes are achieved?
All right, thank you, Dr. Rachel. So became a critical partner with the teacher, right? All right. Can we move to the Dr. Ravi? How rigorous must action research be for it to be considered relevant?
Actually, like Dr. Chu, these questions were meant for all our audience to consider and think about, especially in this workshop. This is a question about how rigorous must action research be, and I think earlier on Dr. Rachel also pointed out to the fact that we actually drew from literature and the ideas of PCK, and particular Jazz Newsom's model, because it resonated with us in our practice, made sense to us. And because it makes sense, because it's a research that has been done for a number of years with PCK way back in 1986-87. So that is one way in which we kind of ensure that the action research that we do it's not just drawn from thin air, or just based on what we see in the classroom, but also based on research. So if you make use of certain frames, like what whether it's Mortimer Squad, or whether it's Schumann's pedagogical reasoning and action. These are all quite established frameworks that we can actually make use of and quite confidently when we share with the teachers and work with the teachers. In that sense, that's how we kind of ensure there's some kind of rigor. But to be honest, I'm not a pure researcher, more of a teacher, educator. So I was hoping to hear also maybe answers from Prof. Pregas or even Dr. Chu in regards to this action research about how rigorous it needs to be for it to be relevant. Yeah.
All right, thank you, Dr. Rafi. Very good response. One important questions: where do we draw the line for researchers who are practitioner researchers of a project to ensure validity in the findings?
This was one of the challenges we faced when we were working with teachers. Initially, when we thought that we had to be quite objective in the sense that we wanted to see how will the three-stage approach turn out with the teachers. We thought we need to refrain from really being involved in it. But we realized it won't work because you need a knowledgeable other in a sense to come into the team, to set them moving, to get them to think of certain ideas which they may have not been thinking about for some time. So that's why we see this three-stage PD approach as an offshoot from probably a workshop that a teacher may have attended on, let's say, on differentiated instruction. And what they've learned from the differentiated instruction, they bring back to the team, and possibly that team can then look at that and look at some of the new ideas or innovative ideas that are shared and then carry out this three-stage approach to try it out in their own classroom and then to reflect on it and then to kind of refine it. And that's where we come from. And I think the line that we need to draw, I suppose since we are not really talking about real research but more of a development project, we were more concerned about whether it would help the teachers help their students learn, and whether they would see that happening in the classroom, and whether they would themselves feel like they are learning something and improving on their own PCK. That was what actually kind of guided us in terms of what we said we need to do with them. Yeah.
I'm sorry, some technical problems. So let me add some information in the Indonesian context. As we much discuss about multi-representation and also STEM education, as in my experience working with the teachers and also pre-service teachers, yes, we pretty sure that sometimes the external factors can be an obstacle for teachers to implement some innovation in the classroom, the rigidity of the curriculum and also the time constraint. But the good news today is our government tried to encourage teachers and also science teacher educators to more implement the innovative approach such as problem-based learning and also case-based learning. So it's gonna be a good starting point for a university, especially our university is a teachers education institution. So it can be a good relationship to build a collaborative between our university as science teacher educators and also schools where we can implement the innovative we get from the research in our institutions. Okay, thank you.
Thank you, Mr. Faisal. Last question. Can the findings of action research be generalized, Dr. David? Dr. Rafi. Sorry.
Okay. This is from my limited reading. The understanding is that action research, although it is conducted in a certain context, under certain purpose, it is more important for whoever listening to that sharing, finding out from the sharing, to think of their own context and how they can then apply it in their own context. So rather than to take whatever is you hear from someone who's sharing on action research in their own context, it is more for you to see how then that would apply in your own context. and to think about it, and to maybe more importantly to try it out and then find out. So I think that's my understanding. But again, I'm not an expert on action research, and maybe the other speakers may want to share more on their ideas, and I'd really like to learn from them.
No, I agree with you. Action research is what it says. It's action taking place in classrooms, and you can report it as valid and reliable research, and it's going to be contextualized. So you cannot sort of generalize from it, but you're going to have situations within it that are generalizable to anybody. And I'd just like to make a point about this issue that Dr. Chu is talking about with STEAM. I've been in classrooms here in West Australia with teachers and trying to encourage teachers to do group work and in science. And the teacher says, the student doesn't know how to do group work. And I say, you know what? These students are in English, are in social studies, and they do group work. They know how to do group work. You don't know how to teach with group work. So once they get that idea and introduce group work, the students naturally do group work because they're doing it in other classes, not in science. So the teachers don't necessarily talk to each other in other disciplines. So that was a revelation for me when this happened. Yeah. Do you relate to that, Hayam?
Yeah,
You have that experience?
based on my experience in the classroom when we implemented STEAM, the group work were facilitated because the topics could familiar with all students in the group. So everyone can participate to solve the problems in different ways. Some students will talk about science, but some students will talk about from more art perspectives or cultural perspectives. So I think to have a successful work, choosing the task will be very important, not only for one or two students, but for everyone can participate. I think those kind of the skills and beliefs by teachers, and if they really want to implement and see how it goes in the classroom, it could be useful action research.
The teachers often have this knowledge, but they don't know it.
For answering those questions and for the great presentation, it was a pleasure and honor to have you with us. Maybe there is a last statement from Dr. Rezel Rugurelo, so I'll take it over to Dr. Rezel.
Thank you all so much for your participation. I appreciated listening and being able to facilitate questions with you all today and learn from you. And I look forward to continuing to be a part of
together on
action research and science education with this international community.
Yeah, nicely said. Yeah, nicely said. Thank you. Thank you.
Thank you. And I don't know if you have a logistical statement next of what happens now.
Well, I'll take it over to Ms. Chitra. Thank you very much.
There is questionnaire.
I think the
panel discussion session is over, so we will some appreciation for certificate to the keynote speaker and invited speakers. so the representative of the biology department so will give the speakers today that for short ceremony for our deepest appreciation. So, okay, Citra.
All right. Thank you very much for our workshop presider, Dr. Nurwati, and also Dr. Rachel. And now we will give a certificate of appreciation for our keynote speaker and also for our invited speakers, which will be given by the head of biology program in the Faculty of Mathematics and Natural Sciences, Universitas Negeri Makassar, which will be represented by Professor Oslan Jumadi, MPhil, PhD.
Thank you. Thank you, Dr. Citra. Dr. Citra. Should I start? Okay. Should I start? Okay. Thank you very much. Thank you very much. With appreciation to our speakers today. To Professor David. As a keynote speaker today, Dr. Stu and Dr. Pinrang as an invited speaker. Many thank you to present the visionary guidance and the best example of action research in science education. We are as a Faculty of Mathematics and Science, particularly from Department of Biology, to present the certificate. So please receive our appreciation and honors. Please.
Okay, thank you. Okay, thank you.
Thank you, Prof. David. Thank you, Prof. David.
Thank you. Oh, wonderful. Okay. Thank you.
Next, to Dr. Yu Ensu. Thank you very much. Thank you very much. To Dr. Su. Okay. Okay. Thank you. Thank you. Please, Dr. Thank you very much. Also, thank you very much to present the great speaker today. Thank you for all. And yeah. And thank you for Mr. Faisal. Mr. Faisal.
Yeah, thank you very much. Yeah, thank you very much.
Thank you.
All right. Thank you very much for Professor Oslan Jumadi for delivering the certificate of appreciation for our keynote speakers and also for our invited speakers. Today we have a really insightful session regarding the action research and of course on how to implement the practice in the classroom to improve the practice of teachers, particularly in Indonesia. Thank you very much for all the insights provided during the session today.
Thank you very much. Thank you very much.
All right, ladies and gentlemen, that was the end of our session today. But before we close, maybe we will have a virtual photo taking together. So please, I invite to all the participants to open the camera video so that our committee can take a screenshot for all participants joining our virtual international workshop today. All right, our committee already started to take the photo, starting from the first page, please, and second page. We are continue taking the pictures together. Please open your video camera. Thank you very much. All right, enough. Thank you very much for all the participants joining our virtual international workshop today, and I will give the session to Dr. Faisal.
Just for information, so for the online session is ended now, and we will continue the noon session with the face-to-face participants in the Faculty of Mathematics and Natural Science, State University of Makassar. Dan kami mengucapkan terima kasih atas partisipasi Bapak Ibu semua dari pagi sampai siang hari ini. Semoga kita bisa bertemu kembali di lain kesempatan. I'm sorry Prof, I talk in bahasa Indonesia. So maybe now we have a break for lunch and prayer, and then untuk aktivitas for face-to-face activity we will continue at 1 p.m. Thank you.
Alright, once again, we would like to deliver our sincere appreciation for all participants who join our virtual event today. So this is the end of virtual event, and after the break session, we will have an offline session to continue the discussion. And thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Kepada para peserta yang hadir di ruangan ini, mohon untuk kembali ke ruangan setelah isomaf. Pukul 1 di ruangan ini kita akan melanjutkan sesi workshop dengan diskusi. Sebelum meninggalkan ruangan, kami undang Bapak dan Ibu yang hadir di ruangan ini untuk sesi foto bersama. Kami undang untuk Bapak dan Ibu yang hadir di ruangan ini untuk sesi foto bersama di depan. Boleh
Selamat datang di Universitas Negeri Makassar. Adalah salah satu perguruan tinggi negeri yang ada di Indonesia, terletak di Makassar, Sulawesi Selatan. Memiliki visi yang kuat untuk menjadi pusat pendidikan, pengkajian, pengembangan ilmu pengetahuan dan teknologi, dan seni yang berwawasan pendidikan dan kewirausahaan. Untuk mencapai visinya, Universitas Negeri Makassar menyelenggarakan kegiatan Tridharma untuk menghasilkan sumber daya manusia yang profesional dalam bidang kependidikan dan non-pendidikan. Memberikan layanan kepada masyarakat untuk peningkatan kualitas hidup masyarakat. Menciptakan iklim dan budaya akademik yang kondusif sesuai dengan prinsip tata kelola yang baik. Mengembangkan Universitas Negeri Makassar menjadi riset university yang dapat memenuhi kebutuhan pembangunan bangsa. Mengembangkan jejaring atau kerjasama antara pemerintah, swasta, ataupun instansi dan lembaga pada tingkat nasional dan internasional. Adapun tujuan dari Universitas Negeri Makassar adalah menghasilkan lulusan yang profesional yang dapat diterima sebagai warga masyarakat yang berbudi pekerti yang luhur, terwujudnya universitas mandiri yang bertata kelola yang baik sesuai dengan peraturan perundang-undangan, menghasilkan produk ilmu pengetahuan dan teknologi serta seni yang bernilai kewirausahaan, terwujudnya jejaring atau kerjasama profesional dalam bidang pendidikan, penelitian, pengabdian kepada masyarakat dengan pemerintah pusat atau daerah, BUMN, swasta, institusi dan lembaga lain baik pada tingkat nasional atau internasional untuk kemaslahatan manusia. Meningkatkan kualitas penyelenggaraan pendidikan yang syarat dengan atmosfer akademik yang sehat sehingga tumbuh berkembang kemampuan intelektual dan sosial secara terpadu sesama sivitas akademik. Untuk mencapai visi, misi, dan tujuan itu disusun 7 program strategis yang sudah dicanangkan dalam program kerja 2016 sampai 2020. Pengembangan kapasitas dan manajemen organisasi atau lembaga, pengembangan inovasi pembelajaran yang berbasis teknologi informasi dan komunikasi, peningkatan mutu penelitian, pengabdian kepada masyarakat, demikian juga publikasi ilmiah, peningkatan sarana dan prasarana, serta penataan lingkungan menuju kampus yang modern, pengembangan karakter mahasiswa dan alumni, peningkatan tata kelola keuangan dan kesejahteraan dosen, perluasan tenaga kependidikan dan mahasiswa, jejaring kemitraan, dan publikasi antar lembaga. Dalam kurun waktu 2 tahun menjalankan ke-7 program yang strategis, Universitas Negeri Makassar sekarang sudah memiliki 9 fakultas dan 1 program pasca sarjana. Fakultasnya adalah Fakultas Matematika dan Ilmu Pengetahuan Alam, Fakultas Teknik, Fakultas Ilmu Keolahragaan, Fakultas Ilmu Pendidikan, Fakultas Bahasa dan Sastra, Fakultas Ilmu Sosial, Fakultas Psikologi, Fakultas Seni dan Desain, dan Fakultas Ekonomi. Universitas Negeri Makassar telah meraih Standar Nasional Indonesia SNI Award kategori organisasi perguruan tinggi seluruh Indonesia. Universitas Negeri Makassar menduduki peringkat ke-20 sebagai perguruan tinggi non-vokasi terbaik se-Indonesia. Terdapat 31 program studi yang sudah meraih akreditasi A. Program studi yang masih terakreditasi B akan terus diupayakan untuk meraih akreditasi A. Bahkan, ada 4 program studi yang sedang berproses meraih akreditasi internasional. Universitas Negeri Makassar memiliki 104 program studi, baik untuk S1, S2, maupun S3. Jumlah dosen ada 1.185 dengan 191 guru besar dan yang masih aktif sampai sekarang ada 86 orang. Doktor sebanyak 421 orang dan selebihnya adalah berkualifikasi magister. Seluruh dosen di Universitas Negeri Makassar telah mendapatkan gelar magister program Strata 2 sesuai dengan persyaratan Undang-Undang Guru dan Dosen. Dalam sisi kelembagaan, Universitas Negeri Makassar sudah berakreditasi A, yang berarti unggul. Universitas Negeri Makassar meraih predikat pertama nasional dalam kategori perguruan tinggi Satker untuk program realisasi anggaran. Dalam kategori Kementerian Riset dan Teknologi Perguruan Tinggi, dalam aspek kualitas sumber daya manusia, Universitas Negeri Makassar menempati urutan ketiga secara nasional. Ini semua dapat diraih karena Universitas Negeri Makassar memiliki semangat yang tinggi untuk maju dan siap bekerja sama dengan segala pihak, baik internal ataupun eksternal. Dengan demikian, Universitas Negeri Makassar menjadi salah satu universitas yang unggul di tanah air dan kemudian di kancah internasional. Selamat datang di Universitas Negeri Makassar. Adalah salah satu perguruan tinggi negeri yang ada di Indonesia, terletak di Makassar, Sulawesi Selatan. Memiliki visi yang kuat untuk menjadi pusat pendidikan, pengkajian, pengembangan ilmu pengetahuan dan teknologi, dan seni yang berwawasan pendidikan dan kewirausahaan. Untuk mencapai visinya, Universitas Negeri Makassar menyelenggarakan kegiatan Tridharma untuk menghasilkan sumber daya manusia yang profesional dalam bidang kependidikan dan non-pendidikan. Memberikan layanan kepada masyarakat untuk peningkatan kualitas hidup masyarakat. Menciptakan iklim dan budaya akademik yang kondusif sesuai dengan prinsip tata kelola yang baik. Mengembangkan Universitas Negeri Makassar menjadi riset university yang dapat memenuhi kebutuhan pembangunan bangsa. Mengembangkan jejaring atau kerjasama antara pemerintah, swasta, ataupun instansi dan lembaga pada tingkat nasional dan internasional. Adapun tujuan dari Universitas Negeri Makassar adalah menghasilkan lulusan yang profesional yang dapat diterima sebagai warga masyarakat yang berbudi pekerti yang luhur, terwujudnya universitas mandiri yang bertata kelola yang baik sesuai dengan peraturan perundang-undangan, menghasilkan produk ilmu pengetahuan dan teknologi serta seni yang bernilai kewirausahaan, terwujudnya jejaring atau kerjasama profesional dalam bidang pendidikan, penelitian, pengabdian kepada masyarakat dengan pemerintah pusat atau daerah, BUMN, swasta, institusi dan lembaga lain baik pada tingkat nasional atau internasional untuk kemaslahatan manusia. Meningkatkan kualitas penyelenggaraan pendidikan yang syarat dengan atmosfer akademik yang sehat sehingga tumbuh berkembang kemampuan intelektual dan sosial secara terpadu sesama sivitas akademik. Untuk mencapai visi, misi, dan tujuan itu disusun 7 program strategis yang sudah dicanangkan dalam program kerja 2016 sampai 2020. Pengembangan kapasitas dan manajemen organisasi atau lembaga, pengembangan inovasi pembelajaran yang berbasis teknologi informasi dan komunikasi, peningkatan mutu penelitian, pengabdian kepada masyarakat, demikian juga publikasi ilmiah, peningkatan sarana dan prasarana, serta penataan lingkungan menuju kampus yang modern, pengembangan karakter mahasiswa dan alumni, peningkatan tata kelola keuangan dan kesejahteraan dosen, perluasan tenaga kependidikan dan mahasiswa, jejaring kemitraan, dan publikasi antar lembaga. Dalam kurun waktu 2 tahun menjalankan ke-7 program yang strategis, Universitas Negeri Makassar sekarang sudah memiliki 9 fakultas dan 1 program pasca sarjana. Fakultasnya adalah Fakultas Matematika dan Ilmu Pengetahuan Alam, Fakultas Teknik, Fakultas Ilmu Keolahragaan, Fakultas Ilmu Pendidikan, Fakultas Bahasa dan Sastra, Fakultas Ilmu Sosial, Fakultas Psikologi, Fakultas Seni dan Desain, dan Fakultas Ekonomi. Universitas Negeri Makassar telah meraih Standar Nasional Indonesia SNI Award kategori organisasi perguruan tinggi seluruh Indonesia. Universitas Negeri Makassar menduduki peringkat ke-20 sebagai perguruan tinggi non-vokasi terbaik se-Indonesia. Terdapat 31 program studi yang sudah meraih akreditasi A. Program studi yang masih terakreditasi B akan terus diupayakan untuk meraih akreditasi A. Bahkan, ada 4 program studi yang sedang berproses meraih akreditasi internasional. Universitas Negeri Makassar memiliki 104 program studi, baik untuk S1, S2, maupun S3. Jumlah dosen ada 1.185 dengan 191 guru besar dan yang masih aktif sampai sekarang ada 86 orang. Doktor sebanyak 421 orang dan selebihnya adalah berkualifikasi magister. Seluruh dosen di Universitas Negeri Makassar telah mendapatkan gelar magister program Strata 2 sesuai dengan persyaratan Undang-Undang Guru dan Dosen. Dalam sisi kelembagaan, Universitas Negeri Makassar sudah berakreditasi A, yang berarti unggul. Universitas Negeri Makassar meraih predikat pertama nasional dalam kategori perguruan tinggi Satker untuk program realisasi anggaran. Dalam kategori Kementerian Riset dan Teknologi Perguruan Tinggi, dalam aspek kualitas sumber daya manusia, Universitas Negeri Makassar menempati urutan ketiga secara nasional. Ini semua dapat diraih karena Universitas Negeri Makassar memiliki semangat yang tinggi untuk maju dan siap bekerja sama dengan segala pihak, baik internal ataupun eksternal. Dengan demikian, Universitas Negeri Makassar menjadi salah satu universitas yang unggul di tanah air dan kemudian di kancah internasional. datang di Universitas Negeri Makassar. Adalah salah satu perguruan tinggi negeri yang ada di Indonesia, terletak di Makassar, Sulawesi Selatan. Memiliki visi yang kuat untuk menjadi pusat pendidikan, pengkajian, pengembangan ilmu pengetahuan dan teknologi, dan seni yang berwawasan pendidikan dan kewirausahaan. Untuk mencapai visinya, Universitas Negeri Makassar menyelenggarakan kegiatan Tridharma untuk menghasilkan sumber daya manusia yang profesional dalam bidang kependidikan dan non-pendidikan. Memberikan layanan kepada masyarakat untuk peningkatan kualitas hidup masyarakat. Menciptakan iklim dan budaya akademik yang kondusif sesuai dengan prinsip tata kelola yang baik. Mengembangkan Universitas Negeri Makassar menjadi riset university yang dapat memenuhi kebutuhan pembangunan bangsa. Mengembangkan jejaring atau kerjasama antara pemerintah, swasta, ataupun instansi dan lembaga pada tingkat nasional dan internasional. Adapun tujuan dari Universitas Negeri Makassar adalah menghasilkan lulusan yang profesional yang dapat diterima sebagai warga masyarakat yang berbudi pekerti yang luhur, terwujudnya universitas mandiri yang bertata kelola yang baik sesuai dengan peraturan perundang-undangan, menghasilkan produk ilmu pengetahuan dan teknologi serta seni yang bernilai kewirausahaan, terwujudnya jejaring atau kerjasama profesional dalam bidang pendidikan, penelitian, pengabdian kepada masyarakat dengan pemerintah pusat atau daerah, BUMN, swasta, institusi dan lembaga lain baik pada tingkat nasional atau internasional untuk kemaslahatan manusia. Meningkatkan kualitas penyelenggaraan pendidikan yang syarat dengan atmosfer akademik yang sehat sehingga tumbuh berkembang kemampuan intelektual dan sosial secara terpadu sesama sivitas akademik. Untuk mencapai visi, misi, dan tujuan itu disusun 7 program strategis yang sudah dicanangkan dalam program kerja 2016 sampai 2020. Pengembangan kapasitas dan manajemen organisasi atau lembaga, pengembangan inovasi pembelajaran yang berbasis teknologi informasi dan komunikasi, peningkatan mutu penelitian, pengabdian kepada masyarakat, demikian juga publikasi ilmiah, peningkatan sarana dan prasarana, serta penataan lingkungan menuju kampus yang modern, pengembangan karakter mahasiswa dan alumni, peningkatan tata kelola keuangan dan kesejahteraan dosen, perluasan tenaga kependidikan dan mahasiswa, jejaring kemitraan, dan publikasi antar lembaga. Dalam kurun waktu 2 tahun menjalankan ke-7 program yang strategis, Universitas Negeri Makassar sekarang sudah memiliki 9 fakultas dan 1 program pasca sarjana. Fakultasnya adalah Fakultas Matematika dan Ilmu Pengetahuan Alam, Fakultas Teknik, Fakultas Ilmu Keolahragaan, Fakultas Ilmu Pendidikan, Fakultas Bahasa dan Sastra, Fakultas Ilmu Sosial, Fakultas Psikologi, Fakultas Seni dan Desain, dan Fakultas Ekonomi. Universitas Negeri Makassar telah meraih Standar Nasional Indonesia SNI Award kategori Organisasi Perguruan Tinggi Seluruh Indonesia. Universitas Negeri Makassar menduduki peringkat ke-20 sebagai perguruan tinggi non-vokasi terbaik se-Indonesia. Terdapat 31 program studi yang sudah meraih akreditasi A. Program studi yang masih terakreditasi B akan terus diupayakan untuk meraih akreditasi A. Bahkan, ada 4 program studi yang sedang berproses meraih akreditasi internasional. Universitas Negeri Makassar memiliki 104 program studi, baik untuk S1, S2, maupun S3. Jumlah dosen ada 1.185 dengan 191 guru besar dan yang masih aktif sampai sekarang ada 86 orang. Doktor sebanyak 421 orang dan selebihnya adalah berkualifikasi magister. Seluruh dosen di Universitas Negeri Makassar telah mendapatkan gelar magister program Strata 2 sesuai dengan persyaratan Undang-Undang Guru dan Dosen. Dalam sisi kelembagaan, Universitas Negeri Makassar sudah berakreditasi A, yang berarti unggul. Universitas Negeri Makassar meraih predikat pertama nasional dalam kategori perguruan tinggi Satker untuk program realisasi anggaran. Dalam kategori Kementerian Riset dan Teknologi Perguruan Tinggi, dalam aspek kualitas sumber daya manusia, Universitas Negeri Makassar menempati urutan ketiga secara nasional. Ini semua dapat diraih karena Universitas Negeri Makassar memiliki semangat yang tinggi untuk maju dan siap bekerja sama dengan segala pihak, baik internal ataupun eksternal. Dengan demikian, Universitas Negeri Makassar menjadi salah satu universitas yang unggul di tanah air dan kemudian di kancah internasional. Selamat datang di Universitas Negeri Makassar. Adalah salah satu perguruan tinggi negeri yang ada di Indonesia, terletak di Makassar, Sulawesi Selatan. Memiliki visi yang kuat untuk menjadi pusat pendidikan, pengkajian, pengembangan ilmu pengetahuan dan teknologi, dan seni yang berwawasan pendidikan dan kewirausahaan. Untuk mencapai visinya, Universitas Negeri Makassar menyelenggarakan kegiatan Tridharma untuk menghasilkan sumber daya manusia yang profesional dalam bidang kependidikan dan non-pendidikan. Memberikan layanan kepada masyarakat untuk peningkatan kualitas hidup masyarakat. Menciptakan iklim dan budaya akademik yang kondusif sesuai dengan prinsip tata kelola yang baik. Mengembangkan Universitas Negeri Makassar menjadi riset university yang dapat memenuhi kebutuhan pembangunan bangsa. Mengembangkan jejaring atau kerjasama antara pemerintah, swasta, ataupun instansi dan lembaga pada tingkat nasional dan internasional. Adapun tujuan dari Universitas Negeri Makassar adalah menghasilkan lulusan yang profesional yang dapat diterima sebagai warga masyarakat yang berbudi pekerti yang luhur, terwujudnya universitas mandiri yang bertata kelola yang baik sesuai dengan peraturan perundang-undangan, menghasilkan produk ilmu pengetahuan dan teknologi serta seni yang bernilai kewirausahaan, terwujudnya jejaring atau kerjasama profesional dalam bidang pendidikan, penelitian, pengabdian kepada masyarakat dengan pemerintah pusat atau daerah, BUMN, swasta, institusi dan lembaga lain baik pada tingkat nasional atau internasional untuk kemaslahatan manusia. Meningkatkan kualitas penyelenggaraan pendidikan yang syarat dengan atmosfer akademik yang sehat sehingga tumbuh berkembang kemampuan intelektual dan sosial secara terpadu sesama sivitas akademik. Untuk mencapai visi, misi, dan tujuan itu disusun 7 program strategis yang sudah dicanangkan dalam program kerja 2016 sampai 2020. Pengembangan kapasitas dan manajemen organisasi atau lembaga, pengembangan inovasi pembelajaran yang berbasis teknologi informasi dan komunikasi, peningkatan mutu penelitian, pengabdian kepada masyarakat, demikian juga publikasi ilmiah, peningkatan sarana dan prasarana, serta penataan lingkungan menuju kampus yang modern, pengembangan karakter mahasiswa dan alumni, peningkatan tata kelola keuangan dan kesejahteraan dosen, perluasan tenaga kependidikan dan mahasiswa, jejaring kemitraan, dan publikasi antar lembaga. Dalam kurun waktu 2 tahun menjalankan ke-7 program yang strategis, Universitas Negeri Makassar sekarang sudah memiliki 9 fakultas dan 1 program pasca sarjana. Fakultasnya adalah Fakultas Matematika dan Ilmu Pengetahuan Alam, Fakultas Teknik, Fakultas Ilmu Keolahragaan, Fakultas Ilmu Pendidikan, Fakultas Bahasa dan Sastra, Fakultas Ilmu Sosial, Fakultas Psikologi, Fakultas Seni dan Desain, dan Fakultas Ekonomi. Universitas Negeri Makassar telah meraih Standar Nasional Indonesia SNI Award kategori organisasi perguruan tinggi seluruh Indonesia. Universitas Negeri Makassar menduduki peringkat ke-20 sebagai perguruan tinggi non-vokasi terbaik se-Indonesia. Terdapat 31 program studi yang sudah meraih akreditasi A. Program studi yang masih terakreditasi B akan terus diupayakan untuk meraih akreditasi A. Bahkan, ada 4 program studi yang sedang berproses meraih akreditasi internasional. Universitas Negeri Makassar memiliki 104 program studi, baik untuk S1, S2, maupun S3. Jumlah dosen ada 1.185 dengan 191 guru besar dan yang masih aktif sampai sekarang ada 86 orang. Doktor sebanyak 421 orang dan selebihnya adalah berkualifikasi magister. Seluruh dosen di Universitas Negeri Makassar telah mendapatkan gelar magister program Strata 2 sesuai dengan persyaratan Undang-Undang Guru dan Dosen. Dalam sisi kelembagaan, Universitas Negeri Makassar sudah berakreditasi A, yang berarti unggul. Universitas Negeri Makassar meraih predikat pertama nasional dalam kategori perguruan tinggi Satker untuk program realisasi anggaran. Dalam kategori Kementerian Riset dan Teknologi Perguruan Tinggi, dalam aspek kualitas sumber daya manusia, Universitas Negeri Makassar menempati urutan ketiga secara nasional. Ini semua dapat diraih karena Universitas Negeri Makassar memiliki semangat yang tinggi untuk maju dan siap bekerja sama dengan segala pihak, baik internal ataupun eksternal. Dengan demikian, Universitas Negeri Makassar menjadi salah satu universitas yang unggul di tanah air dan kemudian di kancah internasional. Selamat datang di Universitas Negeri Makassar. Adalah salah satu perguruan tinggi negeri yang ada di Indonesia, terletak di Makassar, Sulawesi Selatan. Memiliki visi yang kuat untuk menjadi pusat pendidikan, pengkajian, pengembangan ilmu pengetahuan dan teknologi dan seni yang berwawasan pendidikan dan kewirausahaan. Untuk mencapai visinya, Universitas Negeri Makassar menyelenggarakan kegiatan Tridharma untuk menghasilkan sumber daya manusia yang profesional dalam bidang kependidikan dan non-pendidikan, memberikan layanan kepada masyarakat untuk peningkatan kualitas hidup masyarakat, menciptakan iklim dan budaya akademik yang kondusif sesuai dengan prinsip tata kelola yang baik, mengembangkan Universitas Negeri Makassar menjadi research university yang dapat memenuhi kebutuhan pembangunan bangsa, mengembangkan jejaring atau kerjasama antara pemerintah, swasta, ataupun instansi dan lembaga pada tingkat nasional dan internasional. Adapun tujuan dari Universitas Negeri Makassar adalah menghasilkan lulusan yang profesional yang dapat diterima sebagai warga masyarakat yang berbudi pekerti yang luhur, terwujudnya universitas mandiri yang bertata kelola yang baik sesuai dengan peraturan perundang-undangan, menghasilkan produk ilmu pengetahuan dan teknologi serta seni yang bernilai kewirausahaan, terwujudnya jejaring atau kerjasama profesional dalam bidang pendidikan, penelitian, pengabdian kepada masyarakat dengan pemerintah pusat atau daerah, BUMN, swasta, institusi dan lembaga lain baik pada tingkat nasional atau internasional untuk kemaslahatan manusia, meningkatkan kualitas penyelenggaraan pendidikan yang syarat dengan atmosfer akademik yang sehat sehingga tumbuh berkembang kemampuan intelektual dan sosial secara terpadu sesama sivitas akademik. Untuk mencapai visi, misi, dan tujuan itu disusun 7 program strategis yang sudah dicanangkan dalam program kerja 2016 sampai 2020. Pengembangan kapasitas dan manajemen organisasi atau lembaga, pengembangan inovasi pembelajaran yang berbasis teknologi informasi dan komunikasi, peningkatan mutu penelitian, pengabdian kepada masyarakat, demikian juga publikasi ilmiah, peningkatan sarana dan prasarana, serta penataan lingkungan menuju kampus yang modern, pengembangan karakter mahasiswa dan alumni, peningkatan tata kelola keuangan dan kesejahteraan dosen, perluasan tenaga kependidikan dan mahasiswa, jejaring kemitraan dan publikasi antar lembaga. Dalam kurun waktu 2 tahun menjalankan ke-7 program yang strategis, Universitas Negeri Makassar sekarang sudah memiliki 9 fakultas dan 1 program pasca sarjana. Fakultasnya adalah Fakultas Matematika dan Ilmu Pengetahuan Alam, Fakultas Teknik, Fakultas Ilmu Keolahragaan, Fakultas Ilmu Pendidikan, Fakultas Bahasa dan Sastra, Fakultas Ilmu Sosial, Fakultas Psikologi, Fakultas Seni dan Desain, dan Fakultas Ekonomi. Universitas Negeri Makassar telah meraih Standar Nasional Indonesia SNI Award kategori organisasi perguruan tinggi seluruh Indonesia. Universitas Negeri Makassar menduduki peringkat ke-20 sebagai perguruan tinggi non-vokasi terbaik se-Indonesia. Terdapat 31 program studi yang sudah meraih akreditasi A. Program studi yang masih terakreditasi B akan terus diupayakan untuk meraih akreditasi A. Bahkan, ada 4 program studi yang sedang berproses meraih akreditasi internasional. Universitas Negeri Makassar memiliki 104 program studi, baik untuk S1, S2, maupun S3. Jumlah dosen ada 1.185 dengan 191 guru besar, dan yang masih aktif sampai sekarang ada 86 orang. Doktor sebanyak 421 orang, dan selebihnya adalah berkualifikasi magister. Seluruh dosen di Universitas Negeri Makassar telah mendapatkan gelar magister program Strata 2 sesuai dengan persyaratan Undang-Undang Guru dan Dosen. Dalam sisi kelembagaan, Universitas Negeri Makassar sudah berakreditasi A, yang berarti unggul. Universitas Negeri Makassar meraih predikat pertama nasional dalam kategori perguruan tinggi Satker untuk program realisasi anggaran. Dalam kategori Kementerian Riset dan Teknologi Perguruan Tinggi, dalam aspek kualitas sumber daya manusia, Universitas Negeri Makassar menempati urutan ketiga secara nasional. Ini semua dapat diraih karena Universitas Negeri Makassar memiliki semangat yang tinggi untuk maju dan siap bekerja sama dengan segala pihak, baik internal ataupun eksternal. Dengan demikian, Universitas Negeri Makassar menjadi salah satu universitas yang unggul di tanah air dan kemudian di kancah internasional.
Assalamualaikum warahmatullahi wabarakatuh. Honorable all participants joining our event today, welcome to the third session of our workshop today. In the third session of our workshop today, there will be several activities, including presenting the project plan and model. And for our session this afternoon, we will have Dr. Hayan Chu, Dr. Rachel Ruggiero, and also Dr. Faisal as the workshop facilitator, as the workshop presider, Dr. Rachel Ruggiero, and also for the speaker for our session is Dr. Hayan Chu. And without further ado, I would like to hand over the session to Dr. Faisal.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So we will start soon the second session or noon session of the workshop because one of our speakers, we have a different time, 12 hours. So Dr. Rachel Ruggiero, we are sorry for this time difference. So yeah. And also before we start the discussion session, so let me first introduce our project. So the name of the project is Linking Science Education Program, or LSEP 2020. This project is funded by the National Association for Research in Science Teaching, or NARS. And this year, I, Dr. Hayan Chu and Dr. Rachel received the funding from the NARS. Our project this year, let me explain shortly about the LSP. So this year, the LSEP program aim to improve the science education around the countries, particularly for developing countries, and also encourage NARS members to contribute their expertise and also experience in the different regions and countries about the science teaching practice. And also this is the commitment of NARS for improving science education research in the different cultures, and as a responsibility for improving scientific literacy of global citizen century. This year, we received the funding. The project team consists of Dr. Hayan Chu. Could you please say something to the participants? Dr. Chu?
I think the Faisal, she said her camera wasn't working and she may have left the session, but we'll be back. It says in the chat. It says in the chat.
Okay, I will. Okay. So the next member is Dr. Rachel. So please, if you want to say something to the audience here.
I just want to say hello and thank you. It is 1:45 in the morning here. So as Dr. Faisal said, I am trying my best to stay awake, and also very privileged to be a part of this project team. And I can see the audience because that is very helpful to know who is in the room. So welcome.
Yeah, they are surprised. They know we have a 12 hours difference, so they are so sorry. So
it is. We are exactly 12 hours when Dr. Faisal and I are working together. We are saying, 8:30 a.m. is 8:30 p.m. If this workshop is from 1:30 p.m. to 3 a.m. to 3 p.m. Oh, Dr. Hayan Chun is back. But I am excited to be with you all and appreciated the morning and everyone's participation.
Okay, Dr. Chu, I just explained shortly about the LSP project this year. So you may want to say something to the audience here.
I hope we can have a great time for next 6 months. So conduct planning and implementing as well as summarizing all our work. And at the end, I hope we can present it at next year. Thank you.
Okay, thank you. And so I don't think I need to introduce myself, so let's move to the next slide. So this year we have a project title, Improving Science Education in Indonesia Through Action Research, a collaboration between science teachers and teachers educators. So this is our project title, and the purpose of this project is to raise Indonesian science teachers and teachers educators to understand about the action research, the theory and the methodology. The ELSP project 2020 agenda is consists 3 stages. The first workshop is today, June 23rd. We combine online and face-to-face activity, and we engage teaching staff from the university around the Indonesia, and especially for teaching staff in our faculty. The purpose is teaching staff will share their experience about action research and also sharing their ideas about teaching and learning science. The next workshop will be held on July, second week on July. Same activity online and face-to-face. Also, we will invite teaching staff and also teachers from the science teachers from the schools as participants. The topic will be more technical about the methodology of qualitative, quantitative, and mixed methods. And we will also have a session to discuss a possible research topic. And in the second workshop, we will create an action research group between teaching staff and also teacher. And the next step is a local conference. We will invite the group of teacher and teaching staff to present their proposal or their report of action research. Between second session and third session, we will engage teaching staff and also teachers. We will encourage to work collaboratively to design an action research project, and also we will use several online platform for sharing teaching and learning resources and also action research project. We will also have discussion, synchronous and asynchronous, to support the group of teacher and teaching staff in planning and preparing their presentation at the end of this workshop. So the next slide is more about the action research model that we will use for this workshop. So maybe Dr. Rachel will explain about this model. So please.
So I appreciated Dr. Ravindran sharing information about his model for action research and around PCK and professional development. And this is a more broad model that we can use to think about if you want to do something like improve STEAM integration in your classroom, or try to do different modes of representation, how can you use a model of improvement to figure out how to make it work in your context? So something that we heard a lot about is that action research is very context specific. And so this model for improvement thinks about as educator or a teacher educator saying, thinking, what do you want to accomplish? Then going to your hunches as an educator. You have intuition, you have a lot of knowledge, practitioner knowledge. What theories are out there that you can think about? What are the research ideas that you might have to help you figure out what changes you could make in your practice that will result in an improvement? And then how you know that the change is an improvement. So this idea that you want to consider what kind of data you would collect to help yourself understand what you're doing and what impact it's having on your practice. And so this model for improvement can be used as a teacher educator or as teachers who are applying this to their own classroom practice. And this step-by-step process talks about that you can start very small. It can be in one class or with a couple of students. And as you figure out what is working, you can do follow-up tests with more students or with a colleague or a partner, and continue to get to a place where this practice, this research practice is working for you in your classroom. It's giving you the outcomes, student outcomes. This innovation that you're trying is giving you those outcomes that you need or want to make, and then you can share it with colleagues. They can try it in their classrooms, and then you can think about how you share it more broadly. That might be, and many of these questions were posed in the panel discussion about how do you make these innovations happen, and how do you help students do this? What is action research? Is it generalizable? And I think this is a way to say you try it in small settings, you see if it works in other contexts, and it's also a way to spread your ideas in your context for students, but also then to share more broadly, like at the NARS presentation. And this is a model for how I do a lot of work with teachers and thinking about doing research in their own classrooms and doing it in a very reasonable way. That feels, we heard a lot in the morning session of time being a barrier, right? We all know that no one has enough time. We feel like teachers don't have time, we don't have time, it's very difficult. And so how do we do this in a manageable way? And so asking teachers to think, what do they want to try? And what do they want to learn from doing this? So this idea that you both try something in order to learn something about it. And then what is, as all of you are science teachers in science, we make predictions, right? We say, if I do this, then this, we teach the hypothesis. In the same way, we can apply that to our teaching. If I do this one thing, what do I predict is going to happen? What do I actually think will change? Do I think I will have more student engagement? Do I think that I will have changed teacher beliefs? Do I think that I will change student test scores? What is actually the thing that I'm trying to improve? And how much of that will happen? And then what data will you collect to test those predictions and figure out what happens? So this first three boxes at the top is really about the plan, coming up with a plan of what you want to do, what you hope to learn, making a prediction about what you think might happen as you test this in your classroom, and then thinking about what data sources you might need. And as Dr. Faisal said, some of those are quantitative data, some may be qualitative data, and any source is good if it is helping you learn what you want to know. And then the second part is the reflection or the study phase of this model for improvement, where you study the data you collect and you reflect and say, what actually happened? What did I do? Did I implement this thing? What data did I get? What does the data say? What did you learn about this idea? But then also, what is that going to tell you about what your next steps should be? And so this is one model for improvement that we are introducing today as an idea to get us started in discussions and share another framework for thinking about action research. As we think about, as Dr. Faisal mentioned, our goals for saying, what is our experience with action research? What do we want to know more about? How will we take this workshop to be a jumping off point?
So that's a sort of description about our project and what model we will use during the workshop as the face-to-face participation in this workshop. We will. Hello, Dr. Chu.
Yes.
Okay, for this session, we will make a group of the teaching staff, right? Yes, consists of 3 to 4 and then yes, the staff here will support us to record the activity of each group, and the group will have opportunity to discuss about the questions in the worksheet activity, and then you may give feedback or suggestion from the teaching staff questions, right? So please make a group 3 to 4, and then I will share the questions in the chat room. Could you, Dr. Chu, could you see the list of the questions in the Google form in our
Okay.
Boleh, terserah. So in the Google form we have about 10 questions. So do you think we need to okay, what is something from
So
we
I
will start
think
with the
we talked about these questions being maybe, I don't know if we have to do small group for these ones or open this for the group to share here. Dr. Faisal, whatever you think. We came up with these as discussion questions. And then the other questions were sort of ones we wanted to maybe get some written ideas down for.
So we will, I think we can start with the first 4 questions, and then let's see what the teaching staff responds, and they may have some questions from the.
At least for me, as a part of the team, these things will help me understand as well to hear from the staff what they're thinking right now.
Okay. Yeah. Okay. So they may have asked directly to us if they have some questions about. So please, in the chat room we have a link. Bapak Ibu can open the link and then answer the questions. So, but if you have some questions or unclear, you can ask directly to me or to Dr. Rachel and also Dr. Chu. Dijawab, you can answer in Bahasa Indonesia, so me or Dr. Nurwati can help to translate. Yeah. 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 Bisa dikerja online? Yeah. Iya, diketik aja you can type in the. Yeah. Yeah, you can type it online, so Dr. Chu and Dr. Rachel can see your. You can answer in English if possible. So even the main ideas, you can write the main ideas. Okay. 4, yeah. Yeah. Okay, yeah. Okay, yeah. You can discuss, yeah. So please discuss, and then yeah. Oh yeah. Bapak Ibu bisa bertanya langsung. So you can raise hand if you need if you have a questions, and then
I think you can also talk if you want.
So I speak in Indonesian. Ya, jadi saya begini Pak Faisal, mohon disampaikan untuk sharing pengalaman membimbing mahasiswa. Sudah ada beberapa mahasiswa kita bimbing untuk penelitian tindakan kelas. Ya. Namun sekarang di jurusan kita, jurusan biologi, sudah berapa tahun sudah tidak ada lagi penelitian tindakan kelas. Menurut saya, penelitian ini amat sangat penting. Bagi seorang guru, ini adalah sarana yang sangat bagus untuk meningkatkan keprofesionalan seorang guru. Karena dia melakukan secara langsung, mengatasi secara langsung masalah pembelajaran yang dihadapi. Problem yang dihadapi oleh mahasiswa kita adalah kesulitan untuk melakukan penelitian tindakan kelas sesuai dengan prosedur yang sebenarnya. Saya menyimpulkan bahwa penelitian tindakan kelas yang dilakukan oleh mahasiswa selama ini lebih bersifat penelitian eksperimen dengan desain one shot design atau one shot case study. Ya, satu kali putaran, dua kali putaran langsung menyimpulkan, ya kan? Padahal kalau Hopkins sebagai pelopor, salah seorang pelopor action research, itu penelitiannya minimal sampai 1 semester, bahkan sampai 1 tahun. Data yang dikumpulkan itu berupa catatan-catatan harian. Jadi itu yang jadi problem kita. Jadi barangkali memang perlu ada pencerahan kepada kita semua dari para narasumber, bagaimana semestinya itu penelitian tindakan kelas dilakukan agar tidak mirip dengan penelitian eksperimen dengan desain one shot design. Saya kira itu Pak Faisal, terima kasih.
Hello, Dr. Chu and Dr. Reza, one of the teaching staff here. Have a questions about the classroom action research. So today's in our department, the trend of the action research for the undergraduate students is decreased. So my colleague here asks about the how to design the procedures of the action research that will different with the experimental design. So some classroom action research here have a similar method with the experimental designs with one shot design. So the staff asks how to help students to make a different approach or methodology between action research and experimental design.
I'm I'm not sure whether I understood the question correctly. And Faizan, so the question is what kind of research methodology, various research methodology in action research, or what are the differences between action research and experimental design? What was the question?
Yeah, the right procedure of the classroom action research, because sometimes here the teaching staff find the students say this is the action research, but when they read the methodology, it's more to the experimental design. Yeah, one should. Yeah.
I think action research starting from teachers' observation or recognizing about the problems in their classroom. So, of course, when we have collaborative action research between staff and teacher, academic staff influence teachers' action research at the designing stage. So it's like teacher plans something, observe something, find the problem, then plan some action, collect data, then reflect about data, redesign, re-implementation. Like Rachel shows you the cycles, first cycle, second cycle, third cycle. I think that's the different experimental design. It cannot avoid experimental design, but our research experimental design finish pilot test, then test. Then the action research is the roof is really many cycles.
Is there any a certain period, for example, 2 weeks, 3 weeks, or 1 semester for the to complete an action research? Because the students here sometimes design their action research only for 2 meetings. The first meeting and then the second meeting, and then the research is done for the undergraduate thesis. So you may have some experience what the good duration for completing 1 cycle or 2 cycle of the action research.
For undergraduate students, we have the similar small action research pre-service teachers. The minimum action research cycle we make them to run first, then revise something, then run the second cycle, so they can see the differences student changes. Like pre-post could be the minimum kind of action research, one cycle. But that's for undergraduate. But if we wanna do action research publication, or teacher conference, not undergraduate. What we needed to do at least 2 to 3 cycles. Maybe Rachel can.
I would say the cycles, depending on what you're trying to figure out. The cycle may take only 1 week or 2 weeks. The first one, but then it may take another 1 to 2 weeks as you adapt that idea. And then when we think about a collaborative project, which I think we are talking about with other colleagues, they may try it also, and there is like, is it transferable to another context? Do you find the same kinds of data in this other context to create a collaborative action research project where you are testing something in your own classroom over, as you said, Dr. Faisal, a couple of weeks or maybe a month, and then you test it again, and then you work with someone else in your building or another colleague until you get it to a place where you feel like it will work for more than just you as an individual, and you can say that this is something you want to take up, and also share what you have learned about the process, so that it is about the outcomes for your students and what the data says, but also what you have learned and how it contributes to the field.
Oke, mungkin itu Pak, jadi nggak perlu disalahin sama Pak Di. Oke, and let's see the response from the teaching staff in the Google documents. So
I can see someone mentioned doing collaborative research with a teacher at a high school. In the Google document.
So here, collaborative research means working with school teachers. Maybe Pfizer. If you turn off the music in Indonesian, I will try to use Google Translator whether I can do it. Maybe you say something in Indonesia. Anyone want to try Indonesian? I will see whether it works.
Assalamualaikum warahmatullahi wabarakatuh. Thank you for occasion. I wanna ask about the action research. Jadi saya punya beberapa pengalaman terkait dengan penelitian tindakan kelas, khususnya pada saat kegiatan visitasi di sekolah-sekolah. Nah, ternyata di sekolah itu jarang sekali melakukan yang namanya refleksi. Jadi refleksi diri itu sangat jarang sekali. Bahkan tidak ada terkait dengan bagaimana tanggapan siswa terhadap proses pembelajaran, kemudian penilaian dari teman sejawat. Jadi guru-guru itu hanya menunggu supervisi yang dilakukan oleh kepala sekolah. Nah, mengingat permasalahan yang terjadi seperti itu, secara otomatis penelitian atau action research ini tidak dapat terlaksana. Nah, kira-kira kalau kita kaitkan dengan LPTK sebagai penyedia nantinya calon guru, kira-kira seperti apa baiknya kurikulum yang ada di perguruan tinggi sehingga loss yang terjadi di tingkat sekolah ini itu bisa dihilangkan. Karena mau tidak mau kalau kita lihat di beberapa negara itu betul-betul mereka mengkaji apa permasalahan di kelas mereka dan dicarikan solusinya. Jadi seperti mungkin STEM yang sangat menarik sekali tadi dijelaskan terkait dengan fisik, itu betul-betul melatih peserta didik untuk berpikir secara global. Dalam hal ini mereka menggunakan berbagai perspektif, bukan hanya dari segi ilmu fisikanya, tapi unsur biologinya, bahkan matematiknya dan artnya juga masuk. Seperti tadi yang bagaimana cahaya itu berpendar, kenapa sampai di malam hari, itu betul-betul dianalisis oleh siswa. Nah, kira-kira kalau misalnya terkait dengan materi biologi ketika di STEM kan, itu apakah harus secara keseluruhan juga komponennya masuk di dalamnya ataukah bisa dipilah-pilah? Mengingat biasanya di RPP yang dikembangkan dengan pendekatan STEM ini, guru-guru itu masih kesulitan menggunakan pendekatan STEM ini. Jadi mungkin ada dua tadi pertanyaan saya terkait dengan action research, seperti apa kurikulum di perguruan tinggi, kemudian STEM itu sendiri bagaimana membelajarkannya khususnya pada pelajaran biologi. Terima kasih.
Okay, thank you. Let me interpret the questions from Ms. Arifa Novia Arifin. According to Ms. Arifa Novia Arifin, her experience related to action research classroom or classroom action research very rarely conducted reflection, Dr. Chu. So how to prepare our pre-service teacher, especially in the higher level of or in the university, to prepare them to be a good teacher. What about the curriculum related to the STEM, and then for the biology subject, when will be a cure or when the best what kind of subject that the best thing to conduct this STEM approach? Thank you, Dr. Chu.
So why does there less reflection in teacher education program? Could you tell me why? Because reflective practice is the key in teacher education in Australia. So we try to implement 4R, 5R, all reflective thinking process. Could you tell me why at the action research classroom you cannot implement reflection always?
Actually, according to Ms. Arifa, she always conduct this action research classroom, but they sometimes didn't conduct it the reflection, Dr. Chu. What about the significant things of the reflection for you? What is the important thing of the reflection? And what about the curriculum in the higher education, especially for the pre-service teacher? How to prepare them to be a good teacher with this STEM approach, Dr. Chu?
Okay, so reflection is the key in teacher education, and the action research or any kind of classroom-based study conducted by pre-service teachers, even in-service teachers. It's because reflection does not the idea into does not only reflect about reflect about what I learned. Reflection actually connected to justify or explain what I planned, and then describe what I implemented, and then justify the approach related to theory. Then they have to look at the evidence they collected and critically reflect about how it's connected to the theory or documents, national documents. Then they have to suggest reflect about the findings and all the research they did. Then they have to think about what I should do next time. So this reflection process for teacher education, higher education, teacher level education. It's really connected. Similar process with action research. They need to collect the evidence about their plan and implementation. But there are steps. Maybe I can provide some articles related to what is OR, what is 5R. In our higher education, we integrate this reflection 5R for all teacher education assignments. So they have to use reflection to complete teacher education program successfully. And second question about I think your question was how
STEM in biology.
Yes, STEM or
Yes,
STEM
STEM, sorry, STEM.
Okay, so it's a hard question because I have the same problem. In the higher education, teacher education, there is no space for us to really bring to STEM and STEM here in Australia. But we are preparing, as I showed you my last slides. We are trying to develop something connected from concept to systems. So if teachers are prepared to connect the system, what kind of relevant different perspectives, areas can be related to biology concept. For example, right now we are developing forest around the school, like urban forest. To develop this one, all of us, me and my student and my graduate students have to think a lot to find the relevant context related to biodiversity, soil erosion, all different science concepts. So we are now starting teacher education related to STEAM. I thought maybe systems thinking is the key. I can bring into teacher education program.
All right, thank you.
Bisa saya tambahkan, Bu?
Okay, yes.
Dr. Chu or Dr. Raisel, do you have any experience? We have questions about, is it possible for undergraduate students to do an action research where they still lack of teaching experience? So from your experience, is it possible for undergraduate students to design and implement an action research, but yeah, in our curriculum they may have lack experience in the teaching practice in school?
Rachel, do you wanna answer to this?
I think if they are student teaching or have access to a classroom, this framework that we are sharing makes it very possible. It can be very short and small the first time. Some of the students that I work with are new to teaching and have very little experience and maybe asking questions like, how do I improve behavior in my classroom, and focused on if it is hands-on and inquiry based and there's many materials, how do I manage materials in my classroom? So I think that the focus question may be different for an undergraduate or a graduate student or an experienced veteran teacher, but this idea of action research, as we think about it as what do I want to learn about my practice, how do I improve, applies at the earliest levels of teaching all the way to being a very experienced teacher, where we're always working to innovate in our practice.
Jadi, can I speak in bahasa? So, yeah, I try to resum your answer. Jadi katanya dibolehkan selama mahasiswa tersebut punya akses ke sekolah, Pak. Ya, hanya, iya, iya, iya. Dek. Iya, iya. Okay. Dr. Chu have maybe. Okay, please, Dr. Chu.
Yeah. We plan the action research for undergraduate students, but we never use the term as action research because we don't wanna threaten them. They don't know anything about research. They don't know about what's action. But we call it as evidence-based teaching. So they have to pick one science concept, for example, physics concept, then do some literature study about physics concept, then think about how I am going to plan my lesson to teach this one physics concept. So they go to school teach the concept as they then collect evidence, how students understood their own teaching, then analyze the evidence, then they have to plan follow-up lesson. So it's exactly following action research. Then I don't ask to implement the follow-up lesson, but there are chances for them to implement follow-up lesson and collect second evidence connected to their follow-up. So these are small-scale action, but we never tell them it's action research. It's action research.
Excuse me, Dr. Chu, do you mean just like thought experiment without action to the classroom? For your students, it's just like a thought experiment, without doing action in the or experiment in the class.
They go to practicum, the school teaching in the middle of year three at the university. So they go to the school teaching twice. Semester 1 and semester 2 for 4 weeks, total 8 weeks. So they have a chance to really teach their planned lesson there and collect student responses. Then follow up lesson. So maybe the teacher education is different. Between Australia and Indonesia, right? Does student go for practicum during teacher education? Right?
You mean teaching practice?
Yes, teaching practice.
Yeah, we have a course. We say PPL ya Pak ya. Internship. Nama mata kuliahnya yang ke sekolah PPL Pak di. Okay. Di school. Okay. So he has a course, namely research method in education, and then she asks his students to go to the school for observation and collecting some information, some data, and then
they try to find out a problem and conduct like observation and interview with the students about what is and teachers as well about the difficulties of the subject or the topic, and then they conduct the research, they implement the approach to enable they can improve the topic at the school.
So I think that's very similar, right? They go observe and go teach, collect the responses, right? Yeah.
Thank you, Dr. Chu.
Yeah.
Any more questions? Any other questions?
Tell us what kind of support do you need from us?
Actually, I'm wondering to know about the time in Dr. Reza Rugelela right now. Is it in Washington, Dr. Reza? What time is it now in there?
It is 2:35 in the morning.
Oh, thank you.
Yes,
So sorry about that, Dr. Reza.
Have been for a while.
Any questions? Still calling for the questions, please.
I see many responses that people are writing with their groups, so thank you also for that, because that can help our workshop project team make decisions about the next workshop and how we can continue to support you.
some of participants here asked me to ask Dr. Rezel the best practice of Dr. Rezel's by using research in your class. Dr. Rezel, please.
The
Will
best
you please
practice.
share your
the
best practice? Yes, yes, right.
A lot of I think as Dr. Ravi was speaking, a lot of how he works with teachers is very similar to how I think about working with teachers. Things that also might be important if their building level principle can be important. I noticed in the notes someone wrote. Teachers are waiting for the principal to supervise them from the classroom to the teacher to the building level principal can be that is really helpful. The other piece that I think is really important for best practice is making it the measurement. So whatever data you are going to collect, practical. So there is a movement here around practical measures, and that might look like a couple of questions on a Google survey or a scale that people put a post-it on their way out of the classroom, and you take a picture of it. But really thinking about data that can be practical for teachers and collected consistently and with integrity, so that you can actually have enough information to make a decision about how those and learn about what you want to know about your classroom.
Yeah, all right, thank you, Dr. Rezel. Actually, I already conducted exchange research as well within 3 different socio-economic background of school, and I come to the conclusion that this action research classroom can reduce the gaps between the socio-economic backgrounds of the school. By improving how the teacher conduct the lesson, what about the relationship with the teacher and the students. So I think for me action research is really helpful, Dr. Rezel, to reduce the gaps between the different socio-economic background school.
Yes, I really appreciate you bringing that up, because I think another best practice really is thinking about equity and focusing on data collection for those students who may be struggling the most, and also in research, a lot of times what we find out is what works for people on average, but it may not work for the outliers, the students who struggle the most, and so action research can help us to adapt and meet the needs of those students in our own context, and pay attention to that variability so that we can make decisions that are best supporting more equitable learning.
Yes, right.
I received one question about is it possible to use statistical inferential in classroom action research as from your, maybe you have students have perform a statistical analysis for in perform the action research, classroom action research. Yeah. For example,
give this one to Dr. Chu. This is about quantitative analysis.
Yeah, Dr. Chu.
So does it mean that the student teachers are they using statistical inferential to do action research? Is it your question?
Yeah, for example, for best practice, teaching best evidence, the trend here, the students using one suitcase design, so they collect the pre-survey or pre-test, and then the give intervention 2 or 3 meetings, and then they did a post survey, and then they perform a statistical analysis. Is it possible for action research approach?
So our classroom, we have about 30 school students in the classroom, right? So I mean, if we have about 30, we can still have a normal distribution. Less than 30, maybe it's really difficult. There are ways for us to check whether we can use the numbers we generated for the to have some reliable findings. I think why not? If your questions really asking about the program conducted, the lessons you taught, then I think if the questions are reliable and you can use it for your action research, then at least you can use maybe t-test works for about 30 sample size. But you have to remember that my question at the end of my presentation, it was how are we going to for example, creative thinking skills, those things cannot measured by question. And there are many things cannot measure by questionnaire, maybe perceptions, attitude, conception. We can measure it using questionnaire. Carefully choose whether it's okay to use questionnaire. It's kind of a small scale action research.
Saya tidak lihat, Pak. Yang mana, Pak?
And in the Google Doc, we have a lot of response from the teaching staff. So, yeah. Okay. Attending. Oh gitu, saya kirim ulang ke Bu Dik. Mungkin Bapak Ibu yang lain masih ada mau ditanyakan? Masih ada mau ditanyakan?
I think all the questions already answered from the Google Doc.
So staff here very exciting to answer all of the questions in English. So yeah, they try to answer in English. So yeah, even we tell that they can answer in Bahasa and Dr. Nurwati can help to translate. But yeah, they are very exciting to answer in English. So yeah, just let them.
Okay, now still working in how will you know that these changes are improvement? What data will you collect? Someone still type in, he or she said discussion, a game may improve the skill indirectly. A game gives experience about how collaboration helps student groups to master a concept. Discussion makes students able to solve problems together with their group, but the discussion may need extra time. And students tend to discuss out of the context data collection. How will you know that these changes are improvement? How will you know that these changes are improvement?
Yeah, I noticed they're talking about the game as a chain, and they're hoping that it improves collaboration. And then wondering if you're doing something like this, like what kind of data are you collecting? Are you collecting? How much students enjoy the collaboration? How much time they spent collaborating? One of the things that I heard that is also part of also about feasibility. As a teacher for doing some of these strategies. And so you can also collect data yourself about how long it takes to do this discussion or to do this game. What is the amount of time it takes to either plan it or to have it happen in your classroom? And is that a reasonable amount of time to spend on that based on whatever the outcome is that you want to have? Because when you think about measurement, there is the measurement of integrity. Did I do this thing? And how long did it take me to do it? And then also like sort of those outcome measures of then once I implemented this game or this discussion, how did it impact collaboration? And how do you figure that out? Measuring how much time students talk, is it a quick survey to students asking them how much they thought the teacher talked versus how much the student talked. That is some of the fun, and I think where the next workshop is going around what are the kinds of data you can collect to help you really know the impact of some of the things that you are trying in your classroom.
Right, Dr. Rezel. Oh, all right. Actually, we still have 10 minutes left, so maybe we only have 5 minutes remain. So, who else can share their work? All right, Ms. Citra will answer. What is your will answer the questions, Dr. Rezel and Dr. Chu.
Check. All right, thank you very much for the opportunity. So regarding the question, what is our current practice in the classroom? Now, we actually don't have a lot of experience in implementing action research, although we realize that action research is very important to improve our professionalism as educator, because through the cycle of action research, finally we will know what kind of method that we can implement if we want the students to have a better understanding on the topic that we are teaching. My current practice in the classroom, in the beginning of the class, I usually try to assess students' understanding regarding the nature of science in general biology classroom. But I use, for instance, question and answer, like, do you think a theory can change? Do you think scientists can use creativity? Something like that. And after I assess that, I try to give an explanation on how the scientists really can use creativity, but because sometimes students say that, no, we can't use creativity in science, for example, or they say that a theory cannot change because it's already developed by the scientists. How can it change? Something like that. So I usually give them example on the history of science, how the theory has changed over time, something like that. But I actually interested to explore more about how can I improve my practice, particularly on how can we design STEM activity for students through action research. I hope I can learn more through this workshop. Thank you very much.
All right. Any comments from Dr. Chu or Dr. Reza?
I think Andy, it's Andy, right? It's Andy, right?
Citra.
Miss Citra. Miss Citra.
Yeah. Mrs. Citra, have a great approach, especially she diagnosing student understanding then try to provide the relevant information. Nowadays in science education, we want students to experience rather than we tell them what are the examples, what are the different things. So related to NOS, we have a victim synopsis, some research paper that I can share with students. They make them to realize whether science is unchangeability, or whether science has subjective or objective, those kind of experience. So always STEM approach. I told you from my talk, we are using mainly teacher guided inquiry rather than open inquiry. But when we work higher grade level like year 11, we open for lower secondary. When we implement STEM activity, still I am using more guided inquiry. So they do something. We prepare something for them to follow the guidelines.
Mungkin selesai Bu Dik. Selesai ya.
All right, thank you very much for Dr. Rezel and for Dr. Chu. Thank you very much for your sharing, for your share about your experience and your knowledge. Very, very insightful. Thank you.
So because we almost 10 p.m. Indonesian time and 3 p.m. and 3 a.m. US time. So I think the time the workshop we will end the workshop, and the teaching staff will complete the Google Docs, and then after this workshop they may have some times to complete the Google Docs, and we will use for designing or for evaluating our workshop today, and also for our next workshop on July, and then so for the next session, as a closing remarks from the head of biology department, so please, Miss Chitra Pratiwi.
All right, ladies and gentlemen, thank you, Dr. Faisal, and also thank you for Dr. Rachel and for the session today. And also for Dr. Chu, thank you for the insight given during the session this afternoon. And ladies and gentlemen, we are now at the last session of our international workshop, Action Research in Science Education. And we would like to deliver certificate of appreciation for Dr. Rachel and also for Dr. Faisal. The certificate of appreciation will be given by the head of Biology Education Department, Faculty of Mathematics and Natural Sciences, Universitas Negeri Makassar, which will be represented by Associate Professor Musawir Tayyeb. For Associate Professor Musawir Tayyeb, the time is yours.
Okay, thank you, Miss Chitra, and thanks for Dr. Zhu and Dr. Faisal for your combined my international workshop in biology department, and as all the staff for department biology department of UNM can say thanks a lot for your combined with me for international workshop action research, and maybe some certificate. Okay, for Dr. Rachel, yeah. Rachel, I'm sorry.
Yeah.
Just explain my
Thank
name.
you. Thank you.
Okay.
Yep.
very much.
Rachel Rogerello. Yes,
Rachel
thank you.
Rogerello. Yes, thank
Okay.
you.
And then for Dr. Faisal. Okay, I think this is enough.
All right. Thank you for Associate Professor Musawir Tayyeb for delivering the certificate of appreciation, and we would also deliver our sincere appreciation for LSEP for designing this insightful international workshop. Thank you very much, and we hope to see you again on the next event on July, and hope that we can collaborate together to improve the quality of science education in Indonesia. And thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
stop.